Good evening, everyone. Am I audible?
Yes, sir, audible.
Thank you,
Yes,
Jatin sir.
sir. Audible, sir.
Yes, sir.
Good evening, everyone. We'll start the session in few minutes. We will wait for a couple of minutes for everyone to join. Good evening, everyone. Am I audible?
Yes, sir, you're audible.
Yes,
Okay.
sir.
Yeah, thanks for confirming, sir. So, yeah, we are on the day 5 of our ATAL online 6-day faculty program. So, I hope everyone had a enjoyable learning experiences for the past 4 days. And our to repeat, our thirst area is a quantum, is mainly about quantum technologies, and the FTP title is on mainly on the quantum technologies with respect to Industry 4.0 alignment. So we had a n number of sessions for past 4 days, which I'm sure is a enriching knowledge experience for all of you. So today we'll be having as a part of day 5, we'll be having two sessions scheduled today. Our first session, as a overall, it is a session number 9. So our session number 9 and today's first session is the topic is quantum metrology and measurement. Means how do we take a measurement in the quantum? How can we how the quantum things can be measured? That is the one interesting topic we're going to see today in the first session. And our the resource person would be again Dr. N. Magesh sir. I'm sure many of you would already be aware of him. He was the one who conducted the foundation of quantum technology session on day 1, which was our session number 1. So, and a follow-up session today, which is a second session, and overall session number 10 is going to be how we are going to design a curriculum and pedagogy regarding the quantum computing. Means mainly how we can incorporate quantum technologies in our college or university curriculum. That is one of the interesting and curious topic. Even I am waiting to listen today. So that would be conducted by our distinguished expert, Dr. Nalini ma'am. So we'll wait for the couple of minutes for our resource persons to join, and we can quickly start with them. Okay, let's begin our day 1, this first session today. So which is on quantum metrology and measurement. So we have our resource person, Dr. N. Magesh sir, and yeah, I am sure everyone have already had an introduction of Dr. N. Magesh sir if you are present on the session 1 of the day 1. So if anyone have missed that session, I'll give a quick reiterate introduction of our distinguished resource person, Dr. N. Magesh sir. So here is a quick introduction of Magesh sir. So Dr. N. Magesh sir is a distinguished academician and a researcher serving as an senior grade assistant professor in the Department of Computer Science and Engineering at Erode, Tamil Nadu. He has over 30 plus years of dedicated service in higher education as well as research. He has established himself as a leading expert in the domains of machine learning, image processing, semantic web ontology, artificial intelligence, and quantum computing. So, his professional journey reflects a balance of strong teaching experience and impactful research contribution. Uh, uh, Education-wise, Dr. Mahesh sir has completed his computer science and engineering degree at Bharatiya University in 1993, followed by which he has completed postgraduate studies at Anna University, and he has also completed his PhD thesis mainly on the semantic image retrieval system from the Anna University. Since joining academia in 1993, he has served as a faculty in many engineering college, starting from the Kongu Engineering College. He has been currently working at the Government Engineering College at Erode. So, in the academic and research area, Dr. Magesh sir is widely known for publishing quality research papers. He has published over more than 22 research paper in international and national conferences, so including quantum computing and latest bleeding edge technologies. So this publication area domains also cover machine learning based employee evaluation systems and ontology construction and knowledge representation and quantum computing. So beyond research, Dr. Magesh sir has also been known as a well-known faculty for providing a quality result. He has been awarded with a 100% result on the subject he has handled. So he has got many award regarding that. So recently he had got one award for the conduction of successful results for his course analysis of algorithms. So, regarding the achievements, Dr. Magesh sir has been recently awarded as one of for a best paper award for topic. The paper presented was enhanced adaptive ACK protected interruption detection system using MANET. Also, he has been a member of Indian Society for Technical Education (ISTE), which is a lifetime member, which he has obtained a lifetime membership, and he has also been advisory committee of many engineering college, including Sri Shanmuga Engineering College and Technology. So his academic excellence and research guidance has been very valuable for the researcher as well as students. So I take a moment of pride on behalf of our institution and department to welcome again Dr. N. Magesh sir for this session. So I hope everyone would be having a delightful learning experience in this session. I welcome to you, sir, and I'll hand over
Okay, sir.
the session to you.
Okay, sir. Sir, just one request. Actually, the share screen option that is disabled attendee screen sharing. I am getting the message as disabled share, post disabled attendee screen like this. Hello.
Okay, Magesh sir. I'll quickly check with the technical team
Dr.
and
Ravi, sir, wait a minute, sir. I will make a co-host
Okay,
you.
okay.
yes, sir. You are co-host now, sir. Magesh sir, you can present now.
Yes, yes. You just enable the screen share. Sir.
I request others to kindly mute your microphones so the session will be peaceful. Yeah.
Sir,
Thank you.
am I audible?
Yes, Magesh sir, you are audible. Please continue.
Just
Magesh sir, yeah, you can continue.
Sir,
I
is
think you
screen
can share.
visible?
Yeah, yeah.
Is the screen visible?
It's visible,
Okay.
sir.
Wait. Is the screen visible, sir?
Uh, Magesh sir, yes, it's visible, sir. Please make a, full screen, sir. Go for a slideshow option.
Okay, 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 sir.
Okay.
Okay, sir.
Okay. Thank you, sir.
Now is it visible, sir? Actually, last class, if I make the to full screen means some portion not visible. Is it now visible?
It's visible, sir. It's visible. Yeah.
Okay, okay, okay. Thanks for the management and Rajeshwar Madam, Ganesh Prasad sir. Again, I am taking the class on quantum metrology and measurements. Actually, already I gave introduction to this quantum computing. Now this class see about quantum metrology and the measurements. Actually, this metrology and measurement, it is related with ordinary metrology and measurement, but quantum metrology, it is somewhat different from the ordinary metrology. This metrology, generally in the engineering and science, that represent the science of measurements. So we are talking about the liter, kilogram. So these are the words used in the metrology nowadays. So this science of measurement, it is metrology. So the experiment or test, it is performed by means of this metrology, designing, conducting, and analyzing the results. This output is given in the form of some units. It is metrology. So here units of measurement, SI units, replaced by this brew of 8 and measurement, this length in meter and mass in kilogram, time in second, this temperature in Kelvin, K. These are the various units of measurement. Here, is it related with this quantum metrology? So, quantum metrology and measurement, it is similar to these things, but accuracy is somewhat high. It is the main aim of the quantum metrology. The area of industrial metrology, this mechanical metrology that maintains and disseminate the national measurement standard in the area of mass, volume, pressure, and dimension, and also this electrical metrology, AC, DC, low frequency, time frequency, and temperature. These are the metrological terms used in this electrical. And also legal metrology, service offered by this legal metrology are mass measures verification, this volume measuring instruments, so dispenser, tankers, meters. So nowadays, daily usage, we are using some metrological parameters in pre-packaging, this mass, volume, length. These are the legal metrology words. Now, see about the quantum metrology. The quantum metrology is a scientific field that employs the principles of quantum mechanics, such as entanglement, quantum correlation, to perform the measures with enhanced precision and sensitivity beyond the classical methods can achieve. By means of quantum metrology, the precision and sensitivity, this can be improved beyond the certain level. Mainly, this metrology uses various principles of quantum terms. Here, this quantum entanglement and quantum correlations, these are used as a part of metrology. This quantum mechanics, this quantum metrology uses the principles of quantum mechanics. Quantum theory was developed by the various persons, specifically the Einstein, Bohr, Schrodinger, and Heisenberg, Dirac, and others. This quantum theory used in this quantum mechanics, this quantum mechanics used by this quantum metrology. This classical metrology and quantum metrology, just a comparison. These classical measurements are deterministic, non-intrusive, and provide the extra values for the macroscopic system. Actually, this macroscopic system, these measurements are determined. These quantum measurements are probabilistic. Why it is called as probabilistic means when already seeing the cubic states, 0 state, 1 state, and 0 1 state. These are the states of cubic. This 0 1 state is probabilistic in nature. So these quantum measurements are probabilistic, inherently disturb the system, and are limited by the principle like Heisenberg uncertainty principle. Actually, this Heisenberg uncertainty principle, just now see this principle as a part of this lecture. In this way, the quantum metrology and the classical metrology are compared. Classical physics describes the macroscopic object like planets. Quantum physics governs the atomic and subatomic particles. Actually, here these particles and waves, this get in dual in nature. So it is the main comparison between classical metrology and quantum metrology. So it is a probabilistic in nature and covers the atomic and subatomic particles in quantum metrology. This wave particle duality, quantum physics inherent unpredictably wave particle duality. This quantum physics follow the wave particle duality because this whenever we see the light, it is a photon. Yeah. When considering the individual light, it is a particle, but it is a wave. Just if you are considering the frequency, it is a wave. So this wave particle duality, where particle exhibit both wave and particle traits, are fundamental role in imaginary numbers in its equation. Whenever the processing this duality nature, here the imaginary numbers plays an important role. So wave particle duality, it is used in this quantum physics. This metrology, it is a science of measurements. Quantum metrology uses the quantum phenomena such as this superposition, entanglement, squeezing to achieve the measurements with precision beyond the classical limits. So classical measurement precision is limited by the short noise and standard quantum limits. The quantum metrology aims to reach and surpass the Heisenberg limits, the ultimate bound set by this quantum mechanic. Actually, in this, it is a noise, some noise percent, yes, the part of this metrology, these noise are removed. Similar to this signal, noise percent in the signal, here this quantum noise are percent. These are removed by means of some of the principles. So it uses the quantum principles, superposition, entanglement. These are the quantum principles used as the part of the metrology. This standard quantum limit. So this standard quantum limit for noise for some optical measurement scheme usually refers to the minimum level of the quantum noise, which can generally be obtained without the use of skewed set of light. Actually, the quantum noise here, this standard SQM, the standard quantum limit that uses minimum quantum noise. The standard quantum limit for high frequency intensity noise of laser is the short noise limit. Actually, if you are taking the laser it is a laser light. Here the noise is present because this laser light is intruded with some other lights. These are called as a noise. There is a standard quantum limit for phase noise, which is reached by this lecture only at the high noise frequencies. Actually, this standard quantum limit that represent minimum level of quantum noise. If you are taking any quantum devices, here the noise is present. Here the minimum level of quantum noise is considered in this standard quantum limit. This quantum metrology, study of making high resolution and highly sensitive measurement of the physical parameters using quantum theory to describe this physical system, particularly exploiting quantum entanglement and quantum squeezing. The field promised to develop the measurement technique that gives the better precision than some measurement performed in a classical framework. Together with this quantum hypothesis testing, it represents the important theoretical model at the basis of this quantum sensing. Just later we see an example, this MRI scan. Nowadays, MRI scan produces more result. I think this quantum imaging technology that process the MRI images. Actually, this ordinary scan and CT scan and MRI scan, some difference exists. Just if you take this MRI scan or CT scan, this other than this XY value, the jet value is also part of this CT scan. So if the quantum processing is added as a part of this CT scan, the accuracy can be further improved. It is by means of this quantum metrology. So this uses this quantum entanglement. Just I am already told about this quantum entanglement. The two particles depends on some parameters. It is a basic principle use of this quantum entanglement. Just if one particle is in India, another particle is in London, means if these two particles are in separate places, next, according to this entanglement principle, if the change occur in one particle, corresponding change occur in other particle. It is the quantum entanglement principle. So this is achieved. This is used in this quantum metrology. So it is also subjected to some testing, some statistical parameters. This testing that gives the bell-shaped curve or normal curve in its actual position. So it is possible in the quantum metrology also. So this quantum measurement, actually our topic is quantum metrology and quantum measurement. Quantum measurement is defined as a process of quantum physics that can distinguish with certainty only among the specific orthogonal state vectors, while non-orthogonal states cannot be perfectly distinguished. So this is related with orthogonal state vectors. Actually, it is some mathematics behind this quantum metrology. So this quantum metrology space that is represented by H, it is called as Hilbert space. In direct notation, the vectors are written as chi. Actually, chi and pi. Actually, these quantum vectors are written in the form of chi and pi. So these are the symbols. Where this chi and pi are simple names or labels of the quantum states. Depending on the circumstance, these labels, which may be either continuous or discrete, may be the energy, photon number, spin or position or momentum of the system among other possibilities. Actually, here the two vectors are considered. One is chi, another one is pi. The state vector chi, called as a kit, this is associated corresponding to the dual this chi. Actually, here the two notations are used. One is kit, another one is bra. Actually, because of this chi and pi notations, this Hermitian conjugate, this is a complex transport that is denoted as this plus corresponding to this state. This chi described by the column vector and its components are chi1, chi2, and pi is represented as a row vector. It is represented as pi star. Actually, this represented as chi and pi. These are the two vector representation. One is row vector, another one is column vector. In this way, the state vector is represented in this quantum state. Next, the quantum measurement deals with the question regarding the precision with which unknown quantities can be estimated or detected. Utilizing the power of quantum mechanics, these advances can be gained over the previously known technique for practical tasks such as parameter estimation, state discrimination, and hypothesis testing. Actually, this parameter estimation, state discrimination, and hypothesis testing, these are the statistical parameters. These statistical parameters are used in quantum mechanics. It is used in prediction of quantum events. This quantum metrology, in history of science, every time more precise measurement made where possible, new discoveries made. In order to get the precise measurement, this quantum metrology is used. The objective of this quantum metrology aims to enhance the measurement precision by utilizing the quantum mechanics principle with very high precision measurements such as length, time, frequency, temperature, physical quantities. This can be measured far beyond what is possible classically. So very high precision measurements, it is achieved by means of this metrology. So this quantum sensing, it is one of the method used in this quantum metrology. It is use of quantum system to make atomic scale measurements. Quantum sensing related to the quantum metrology, which seeks to create the highly sensitive and high resolution measurements of physical conditions using this quantum theory. Concept of this quantum metrology, these classical theories regarding the measurement providing the advanced precision measurements that cannot be considered in traditional theories, the classical estimation theories that follows the central limit theorem, which suggests the measurement error may be reduced by utilizing the amount that is proportional to minus square root of n. Actually, according to this central limit theorem, it is central limit theorem follows the normal distribution. Normal distribution curve is the bell-shaped curve. The error reduced to square n power of, it is according to the central limit theorem. This occurs by repeating the measures by n number of times and then obtain the mean of the result. In quantum metrology, the concept of central length is made easier through the use of quantum effects, such as this entanglement, which limits the error for the amount that is proportional to 1 by n. Actually, here it is minus square root of n. It is according to this central limit theorem. In the quantum metrology, the error, it is proportional to 1 by n. So this is the achievement in this quantum metrology. The quantum metrology uses one of the principle, Heisenberg uncertainty principle. So it is one of the principle used in this quantum metrology. In the field of quantum mechanics, Heisenberg's uncertainty principle is the fundamental theory that explains why it is impossible to measure the more than one quantum variable simultaneously. Actually, this used to why it is impossible to measure the more than one quantum variables simultaneously. Just to see this principle slightly. Actually, these are the various key concepts used here. Standard quantum limits and Heisenberg limits, quantum Fisher information. These are the terms used in this metrology. The precision scale of 1 by n 1 and square root of n into 1 by n. It is a standard quantum limit. We see this later in this. It is according to this photon, using this independent photon in the interferometer. Actually, it is the measurement limit. This Heisenberg limit, it is a precision scale as this 1 by this n1. It is achieved by means of entanglement and other quantum correlation and quantum Fisher information. It is used in the estimating the parameters. This why this standard quantum limit in contrast to this interferentiometer, other optical measurement, the standard quantum limits usually refer to the minimum level of quantum noise which is observable without squeezed states. In additionally, the quantum limit for the phase noise reduced reachable only by the laser at high noise frequencies. Now see about Heisenberg uncertainty principle. According to this principle states that it is impossible to measure or calculate exactly both the position and momentum of the objects. The principle is based on wave particle duality of matter. Already wave particle duality, already we saw the wave particle duality. Although this Heisenberg's uncertainty principle can be ignored in macroscopic world. So macroscopic world, it represents the actual physical world. For example, location speed of moving car can be determined simultaneously with minimum error. But microscopic particle, actually it is macroscopic example. This location and speed of moving car. Now it is easy to see the location of a car and speed of moving car by means of simultaneously location, latitude, longitude that represents the location. Speed, how much speed the car is moving with the minimum error. So in microscopic particles, it will not be possible to fix the position, measure of the velocity or momentum of the particle simultaneously. For example, if the photon is moving, one light ray that is moving from one place to another place, if you are measuring the position means the speed cannot be measured accurately and momentum cannot be accurate. Anyone can be measured, but it is not possible to measure the both position and the velocity simultaneously. This electromagnetic radiation and microscopic matter waves exhibit dual nature of the mass, momentum, and wave character. Just electromagnetic radiation and microscopic parameter, this it is difficult to measure the position and speed simultaneously because of this duality. The electron at the atom has the mass of 9.91 into 10 power minus 31 kg. Naked eye cannot see such small particles. The powerful light may collide with the electron and illuminate it. So illumination helps in identifying and measuring position of the electron. Just if we want to know the speed of the electron means a powerful light collide with the electron and illuminate it. Then only it is possible to know the position and the speed. The collision of a powerful light source while helping in the identification and increasing the moment of electron and make move away from this initial position. Just if the light is if the light is hit the electron, so then only it is possible to know the position, and makes whenever the light move hit the electron means this give some momentum to that light. So the speed is improved. This, when fixing the position, the velocity and momentum of the particle would have changed from the original value. This velocity of the particle could have been changed from original value. Hence, when the position is exact, the error occurs in measuring the velocity or momentum. When position is exact means the error will occur because the speed on the speed the electron hit the particular particle. So this position slightly change, and also this energy or momentum is also changed. In the same, the measurement of momentum accurately will change the position. So the measurement of momentum will change the position. So this is a problem in this micro particles. So hence, at any point in time, either position or momentum can only be measured accurately. Simultaneous measurement of both of them will have the error in the position and momentum. This Heisenberg quantified the error in the measurement of both position and moment simultaneously. So quantified the error. So it is called as Heisenberg uncertainty principle. Technique in quantum metrology. These are the some of the technique. So quantum interferometry and spin QZing, known states, quantum error correction in metrology. These are the various metrological terms. So interferometry, just see this one by one. And spin skewing, it is another one metrology. It is spin skewing. It is method conducted in atom level. This known states, this entangled states of the form. Actually, this quantum computing uses various entangled states. So this, whenever considering these states with respect to the pace measurement in Heisenberg limits, these are called as the known states. These states are used in this metrology. Next, quantum error correction. This quantum error correction used in this metrology. Interference. Interference is the phenomenon that occurs when two or more waves of the same frequency overlap and combine to form the new waveform. It is called the interference. Actually, it is occur in light level and also occur in electromagnetic level and also occur in quantum level. Actually, it is an example for interference. It is a wavelength of two waves A and B. When they are interfere each other, this amplitude is increased. This wave A and wave B, these two are considered. This A plus B, it is the result of these two amplitude interfering. So it is called as interference, because the quantum particle is also wave particle. So this interference occur when the two waves that hits each other. So it is used in this quantum metrology. This quantum interference. The quantum interference is a phenomenon in quantum mechanics that arise from wave-like nature of the quantum particles, such as electrons or photons. So here these electrons and photons, this interference subject to this quantum interference. When the particle is in superposition of multiple states, these states can interfere with each other, leading to the constructive or destructive interference. According to the amplitude of the quantum waves, here this constructive and or destructive interference will occur. So two particles can further increase the amplitude, or according to the nature of waves, they can attenuate each other. Some destructive interference also happen. The interference can result in specific pattern of outcomes when the particle is measured. In quantum computing, this interference used in various ways to manipulate and control the quantum states and to perform the computation task. Applying these quantum gates that creates a superposition of the qubits by controlling the relative pace of the states, the interference can be used to amplify the certain outcomes and suppress the others. By means of this quantum interference concept, some portion of waves that can be amplified and some portion of waves that can be suppressed. It is according to the applications. So this quantum interference that uses this matrix. And spin fusing. Spin fusing is a form of entanglement that reshapes the quantum projection noise to improve the measurement precision. It is this quantum projection noise. The quantum signal is also having some noises. This spin fusing, this projection noise improve this precision, reshapes the quantum projection noise. The noise are reshaped by means of this spin fusing. It is one principle used in this metrology. And also quantum error correction. Quantum error correction is particularly powerful tool for enhancing the precision of this quantum metrology. Quantum error correction is a method for reducing the noise in quantum channel and quantum processor. If the noise is not too strong or too strongly correlated, but the potential value of quantum error correction in quantum metrology has not been fully fleshed out. So this reduce the noise in this quantum channel. It is used in this quantum error correction. The applications, this quantum clock and gravitational wave detection, magnetometry, quantum imaging, navigation and sensing. These are the main applications. Here the quantum metrology can be used. In this atomic clock, this improved frequency standard uses this entangled atoms, gravitational wave detection. This quantum skewed lights used in this LIGO, it is one system, and Virgo, it is another one system. So these are designed for this quantum wave detection principle, and also magnetometry, this quantum sensors for this ultra sensitive magnetic field detection. Actually, this quantum uses the sensors. So this quantum sensor used in this magnetometry, and quantum imaging, that is used in this quantum MRI scan, and navigation and sensors. This GPS related applications uses navigation and sensor applications. These are the challenges in this quantum metrology: decoherence, scalability, and error correction. This interaction with the environment destroys these quantum advantages. Scalability, generating the large entangled states is difficult. Error correction, need to maintain the precision in real world conditions. These are some of the challenges. Just see an application. It is quantum imaging applications. The quantum imaging could be used to create a high resolution image of distant objects such as planets or satellite with the ability to penetrate through the clouds and dust. Here, using the quantum metrological applications, this quantum objects, this planets, satellites, this penetrate through this cloud and dust. Here, high accuracy images are taken by means of this quantum sensing. Just this OCT is optical coherent demography, another name for CT scan. CT, coherent demography. It is a three-dimensional imaging technique with ultra-high spatial resolution, even in highly scattering media. So it is a three-dimensional imaging technique. So it is optical coherence telegraphy based on interferometry. So it is concept is interferometry, involves interference between the reflected light and reference beam. Actually, it is the concept used in this inter CT scan. It is interferometry. It is a concept. So this quantum OCT, just OCT is a optical coherence demography. So it gives the three-dimensional imaging technique. Just we can see the third dimension, Z dimension of the images. For example, by means of the CT scan, any human parts that is taken, that gives the three dimension of the bone or tissue structure. So it is somewhat accurate method, but as compared with OCT, this quantum OCT, it is highly improved OCT. So quantum OCT. This quantum OCT is a technique analogous to the classical OCT, but it with the uses entanglement photons in order to take advantage of dispersion cancellation. It uses this entangled photon. In quantum version, the light source replaced by the source of frequency entangled photon pair from this SPDC. So SPDC, it is a photon downward counter. This interference takes place in this HOM type. Here, the quantum version of the photon, entangled photon, is taken in this light source. This interferometer, instead of this Michelin type interferometer of a classical setup, instead of this interferometer, this optical interferometer, here Michelson type interferometer is used. The semantic of quantum OCT arrangement is shown. This arrangement is intensity to even order disruption and robust against this photon loss. The light source is a nonlinear crystal which produces a signal ideal pair via the spontaneous parametric down conversion, whose spectral distribution is determined by this frequency, this pi of W. Actually, here quantum OCT device, that is one interferometer is used. So the pair has autocorrelate frequency W. In this frequency used in defining this quantum limit, just it is the structure of the quantum OCT. So one nonlinear crystal, it is used, the bump which produces the signal, this quantum signal. This quantum signal fall on the mirror, and another part, it is a beam splitter, another part that fall on this sample. So here again this mirror reflect the quantum signal. Here, the beam separator. This beam separator separates these two signal. These are captured here. After this beam separator, the signals are captured and processed here. Here, the accuracy of this OCT is improved by this quantum OCT. So here, the quantum bump, which generates the entangled quantum signals. So this entangled signals separated here, and it is fall on this sample. Here the waveforms are collected in this beams separator. Here these signals are analyzed. These analyzed signals generate the signals like this. Actually, it is ordinary normal OCT generated output. It is the quantum OCT generated output. Here, more number of suppressions occurs in this quantum OCT. Yes, compared with normal OCT, this quantum OCT is more accurate with respect to its graphical positions. So in this way, this more accurate matrix, it is obtained by means of this quantum OCT. Here, the Fourier transform and quantum entanglement. So this concept are omitted here. Final waveform only generated as part of this. So anyway, the quantum OCT is more accurate than normal OCT. So the accuracy, this matrix is improved, precision value is improved in this quantum OCT. It is one of the application it used in this OCT scanning. So similarly, the location of particular position of cell phone, it is obtained by means of this quantum principles. This quantum OCT was able to determine the location with twice the resolution. This half tips in the top figure are half of the width of the interference structure on the bottom. The visibility of the quantum case was 45%, close to the calculated value of 50%, and nearby doubles the 28% visibility of classical case. Actually, this 28% visibility, it represents the ordinary OCT. This quantum case is 45%. It is close to this calculated value of 50%. So the quantum case is better than the classical case, ordinary OCT. So accuracy is more in this experiment. It is the usage of quantum OCT. The resolution is also high with respect to these images. So it is the measurement by means of this quantum OCT. These are the references referred for this quantum matrix. So these are the things taken from the book. Just I will show the book. I took the material from this book, but it uses more number of calculations. Just some calculations and some kind of transform. Just I omitted this transform and calculations. Actually, this quantum metrology and imaging in this communication system, Actually, this quantum metrology with respect to this imaging system and the communication system, these are explained. More number of calculations used. Actually, the Fourier transform and related calculations exist as a part of this book. Yes. Actually, these are the calculations related to the position of wave. So already I told about two parameters, psi and pi. So this psi and pi, it represents the strength of the signals. The entanglement relationship described by means of the psi and pi. These two signal used in forming the matrix. So according to this values present in this matrix value are processed, and the processing gives the more precision similar to the quantum OCT. It is another one experiment done by means of the quantum principles. So here it is similar to the previous quantum OCT. Here some detectors are used. These detectors are used in processing the results. So similar calculations are used throughout the book. So just use this. It is quantum OCT test. Okay. These are the part used as the part of quantum OCT. Actually, this quantum measurement and quantum metrology that uses the principles, this Heisenberg principle and this quantum OCT and other principles used here. Actually, this standard quantum lead, Heisenberg limit, and quantum Fisher information. These are the main principles used in this quantum measurement. Here, in this OCT example, this Heisenberg uncertainty principle, it is used to generate the wave and to detect the wave in this particle position. So here, this quantum interferometry spin using noon state quantum error correction in metrology. These are the some of the techniques. These techniques used in navigation and quantum OCT methods. Okay, these are the something regarding this quantum metrology. So the quantum metrology is used to measure and used to improve the precision to the next level. The satellite image measuring also uses GPS position. So the GPS position actually uses the quantum metrics in this processing. So as compared with ordinary measurement, the GPS positioning, this improves the precision. It is a kind of quantum measurement. It is also uses the quantum technology for processing and measuring the distance related events. So the precision of measurement can also be improved by means of this quantum metrology. These are the some of the points regarding this quantum metrology. Okay, these are the things covered as a part of quantum metrology and measurement. The quantum theory that uses all these principles. Okay, thank you. Any questions?
Thank you, Magesh, sir. Sir, one of our participant had asked whether if you can share the book regarding the which mathematical references you showed, right? Uh, can it be shared? So,
Okay,
uh,
sir.
yeah. So if you share with our coordinators, yeah, we can share it with them, sir. The slides as well as book. Participants, if you have any question, please paste it in the chat box so we can pick it up one by one. Magesh sir, you are there? Am I audible? Hello? Hello, Magesh sir? Can you hear me? Dear participants, the attendance and feedback link has been shared. While the Magesh sir, we follow up with Magesh sir to join back. I request you to please open the link and provide your valuable feedback and attendance. As Rajeshwari ma'am has already pasted in the group, we need to maintain a 80% attendance in order for the certification of this FTP.
Sir, is it audible?
Mahesh sir, am I audible?
Yes, yes, yes.
Sure,
Sir,
Mahesh.
some problem in network.
Yeah, no problem, Mahesh.
Okay.
Sir, that was one thing they asked regarding the materials which you told. Uh, okay. That will be shared, sir.
Okay, sir. Okay, sir. I will send that. Hmm.
And the session was knowledgeful, sir. Means I know the quantum computing itself is a complicated topic because of its very nature. It's like having
Yes,
a zero and one
yes,
state simultaneously, and measuring it is again a different challenge. It's not like a traditional measure as you told, but
yes,
looking at the application,
yes,
sir, it looks to be having a very deep application of the example which you showed, which is of the MRI scanning, right? The CT scan. I mean,
yes,
the
yes. CT
quality of the
scan.
image which we got.
That
Yeah,
is.
that result was phenomenal. Yeah.
Yes.
One doubt I had, sir.
Some papers, but yes, sir.
Yes, sir. You please
Yes.
continue. I'll talk after that. Yeah. You are telling some papers on WhatsApp.
Okay, sir. You tell. Actually, some delay in reaching the signals. No problem.
Okay. Sir, one doubt I had was like you told for the SI units, we have like a meter for distance and ti seconds
Yes.
for times and similar things. But what is the unit in
Okay.
quantum we measure, sir? Is there any unit, SI unit kind of thing in quantum computing measurement?
Sir, here actually this quantum measurement does not concentrate on unit, but how to improve the accuracy of the conventional system. For example, if you are measuring the length means some methods are there. Just we can measure the length by means of a meter or kilometer. In such a way, we are measuring the length, but the quantum measurement that deals with how to improve the precision. Just if you are surveying a land means the some error, chance for occurring the error because of the conventional method. Nowadays, if you go to survey a field means surveyor uses some other method. We use tape devices, but surveyor uses survey the land properly than us. But somewhat error be present. But if we measure the same case by means of this quantum mechanics means the precision will be more accurate. For example, the MRI scan used frequently in all places. Yes, compared with this MRI scan, this quantum MRI produces very high result. This precision of accuracy is more. Again, the same unit can be used, but the precision is improved by means of quantum metrology. That is aim of the quantum metrology. So again, no change in this SI units and other things. How to improve the
Um,
precision? For
okay,
example, okay, sir. Just I will tell another one example.
okay, sure, sir.
Just two particles are in entangled state. So if the two particle are, for example, if we are taking the two particles, one is in Chennai, another one is in Hyderabad means, first these two particles are entangled in one place. Then these two particles, that is in on position. For example, one particle is in one position, entangled particle that is in zeroth position. If it is one means other particle is zero. It is the meaning of entanglement. The entanglement concept is applied for these two particle means one is in Chennai, another one is Hyderabad means again if we change one as 0 in Chennai, concern change occur in Hyderabad. Otherwise, vice versa. It is possible by means of this entanglement. So this precision is used for metrology. So here for distance measure, the actual position of the particle is known in one place and another one particle is placed in some other places means actual using this entanglement property, this nature of this two particle gives the more fine result.
Okay, okay. Got it, sir. Means there is no particular unit for quantum measurement, but quantum is mainly dealing with enhancing the precision. For example, if it was check means for example, if length was checking in terms of
Capture
millimeter.
these things, sir.
Sorry, sir. Can you hear me?
Actually, the same units are used, but the precision of measurement is improved by these principles, these quantum
Yeah.
principles.
Yeah, sir. Got it, sir. Earlier,
Okay.
if we are measuring by millimeter, we can now go till micrometer or nanometer, like that, right?
Yes. Actually, I am here. Anything is waveform in nature. So the wave property is obeyed for all these things. Here, the wave property means the every wave is having frequency and also macro
Wavelength.
particles and micro particles. This will come under this micro particle nature. So this actually this photon and electromagnetic waves, these are considered in microwave nature. These are not come under this macro format.
Okay. Sure, sir. Got it. I got the answer for my question. Thank you very much, sir.
Okay, sir. Okay, sir.
Okay, if any other participants have question, we can take it up. Please paste it in the chat box. Okay. Sir, looks like no more question as the topic is quite complicated. Yeah, it takes, I am sure it takes some
Yes,
time, ages. But
yes,
as and
yes.
when, if anyone has a doubt, we will tell them to reach out to you for further clarification, sir.
Actually, I go through the one of the books. In
Okay.
this way, this entanglement principle not told that in the author told that this entanglement principle it is in execution level, not in actual implementation level. In this way, the author told, but it is one of the principle used only in experimental level.
Okay.
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 Actually,
Okay.
the author told like this.
Sure, sir. Sure.
Okay, sir. Okay. Thank you very
Thank you
much.
for the thank you very much for the knowledgeable session, sir. I believe
Okay, sir.
everyone has got benefited from it. Thank you
Okay, sir.
again for making your time out of your busy schedule and sharing your
Okay, okay,
knowledge
sir.
with us, sir. Thank you very much.
Okay. Thank you.
Thank you, sir. Dear participants, we take a couple of minutes break to fill attendance and feedback if anyone is not shared. And we'll start our next session in exactly 2 minutes. Our next session would be on curriculum and pedagogy regarding the quantum computing. It will be taken over by our expert resource person, Dr. Nalini ma'am. So we'll start exactly in another 2 minutes. Thank you all for joining this session. I request everyone to continue in this session because we will be, if you close the session, you may not able to join back. We'll be continuing the next session in a 2 minutes time. Thank you. Hello everyone, welcome back to the FTP session day 5. Uh, Today's session, as I told earlier, it's on the curriculum and pedagogy regarding quantum computing. So our distinguished resource person is Dr. Nalini ma'am. So uh, I'll give a quick introduction of Nalini ma'am for those who have joined newly for this session. If for others, this could be repetition as she had given a session 3, means our day 2 first session was handled by Dr. Nalini ma'am itself regarding the quantum computing algorithms. So I'll give a quick introduction again of Nalini ma'am. So, Dr. Nalini ma'am is a distinguished academic and research professional with over 26 years of teaching experience. And as a researcher, she has completed over 19 years of research expertise, which is phenomenal. She is currently serving as a professor in computer science and engineering department at Nitte Meenakshi Institute of Technology, Bangalore. She holds a master degree from BITS Pilani, Goa, and a PhD from VTU, Vishweshwaraya Technological University. The PhD thesis was submitted and awarded. Degree was awarded in the year 2007. So her contribution includes a lot of research publication, including book chapters, and she has also have few patents in on her name. So she was coming to the achievements. She has been awarded numerous awards during her career, out of which few of them are Bharati Jyoti Award, which was awarded by International Friendship Society at New Delhi, which was presented by the ex-governor of Tamil Nadu and Assam, Sir Shri Bhishma Narayan Singh sir. In 2014, she was honored as a Dr. Abdul Kalam Lifetime Achievement National Award for her contributions in teaching, research publication, and administration. Additionally, she was recognized as a distinguished professor by Tech Next India in 2017 in association with the Computer Science Society of India, CSI, which awarded her a Best Professor in Computer Science and Engineering. So, as a part of the college activity, she has been known for being proactive and her leadership qualities. She has been elected as a vice chairman cum chairman elect of the Computer Society of India for the Bangalore chapter, and she was also program chair for international conference on emerging research in computing, information, communication, and application, which is ERCICA. So along with that, Dr. Nalini ma'am has done a lot of membership and organizational involvement. She has been in the all key committees of NMIT and has been a great valuable committee head for our college. And for all the phenomenal work which I mentioned, she has been recognized as a as a great scientific researcher by AD Scientific Index, and she also serves as a chairperson of an international compliant committee at NMIT, and she has been a guiding force for many other academic organizations, such as she has been at academic council at SSIT, Sri Siddhartha Academy of Higher Education at Tumkur. Coming to the membership, she has been a part of ISTE, that is Indian Society of Technical Education, Computer Society of India, and Association of Computer Engineers and Electronic Engineers, which is abbreviated as ACEEE, and the Indian International Friendship Society (IAFS). She has also been a member of a technical committee and reviewer in the numerous national level and international level conferences. So it's our privilege for Sridevi Institute of Engineering Technology and Department of Computer Science to have such a distinguished resource person among us for this today's session. I heartily welcome Dr. Nalini ma'am for this session. Welcome, ma'am, and I hand over the session to you.
Yeah, thank you, sir. Thank you so much for the introduction. A very good evening to all of you. Let me take over. As such, not exclusively prepared this curriculum and pedagogy for the this quantum computing exclusively, but I thought generally I will introduce this. Said that for any kind of subjects, it should be applicable. So it can even be applicable for quantum computing. So with that introduction, hope the slides are visible. I have shared the slides.
Yes, ma'am, it's visible.
Okay, I will move on to the slideshow mode. Okay, is it visible now?
Yes, ma'am. Slideshow
Okay.
is visible. Yeah.
All right, so I will take over. I think already fag end of the day, I'm sure, but nonetheless, some of the information will be very helpful for we teachers when we teach to our students, because nowadays everything is changing very swiftly from the classical way of teaching, how it should be, how we need to prepare our students for the future. So many changes are happening, and with the introduction of things like Chat GPT, etc. And we also need to have something related with respect to those things and accommodate whatever is required for our students. So in that context, I will also be giving an example how we prepared a lesson plan this time with the help of this AI. So I will let you know about that in the end. But meanwhile, let me cover some of the things. Not in detail I'll be covering, but all of you will know where what I am trying to tell. So with that agenda and this learning framework, let me give you a comprehensive session overview, understanding curriculum development foundations and principles, exploring modern pedagogical approaches and methodologies, because modern pedagogical approaches is the need of the hour. It's not like earlier we used to go to the classrooms, make use of the chalk and board. Then came the style sheets. Most of us, I guess, know about the style sheets. We used to write on the OHP sheets and then project it using the projector. Most probably, many of you might not know about that, but we used to do that. And that was the advancement for us, actually, taking the style sheets, writing on the style sheets with a permanent marker, and then taking it and OHP projectors, like style sheet projectors were there actually. So we used to keep it on that and it used to project it on the board. So that was the little advancement which we learned. Then came the overhead projectors. And now we know that all of us, mostly in almost all the institutions, we are all using that. That was about like how we are projecting our contents of the syllabus or the teaching things to the students in a different ways. So not only these things, apart from these things which are basic, very fundamental nowadays, lot of other things are initiated, and in everyday class we are being asked to implement and we have been asked to incorporate. And you all know that nowadays everything, the proof is required, right? I mean, I'm just bringing why all those things are required means what we are doing it to our students, we need to have a proof of the things. So therefore geotagged all those thing photos almost, I'm sure, honestly I'm telling, every one of us might have been asked to do that, because that is the thing which is required for so many committees, etc., right? So like what is it that we have been doing compared to traditional ways? So exploring modern pedagogical approaches and methodologies, analyzing the assessment and evaluation techniques. It is not just blue book correction and entering the marks somewhere. Nowadays, this assessment and evaluation techniques also have been getting changed. So examining this NEP 2020 reforms and their implications, and implementing technology enhanced teaching strategies. This is the need of the hour, technology enhanced teaching strategies. So let us look into some of the things which we are also using at our institution. Mostly, almost all the institution, all the participants over here agree with me. You are also in some way or the other using all these advanced technologies. But let me discuss in detail about so many of the aspects. So detailed topics for discussion: curriculum development, theory, design and implementation, then pedagogical foundations and modern teaching approaches, assessment strategies and educational evaluation techniques, National Education Policy 2020 transformative changes, technology integration in curriculum and pedagogy, student-centered learning and active pedagogies. It's not teacher-centered. Almost everybody would have been told by this time. It should be student-centered. Then inclusive education and differentiated instruction. What is the meaning of this also we need to look into. Then quality assurance and curriculum evaluation. Then professional development and teacher empowerment. It's not that teachers should be stressed, overstressed or something like that, but empowered to do the creative things to enhance the quality of education and outcome of the student. So outcome-based education, all those things we know it already because of NBA and etc. But in what different ways this outcome can be achieved, all these things we need to look into. So whatever best practices we are following at our institution, I'll try to bring it down to all of you, and also whatever I've been collected, the information through various sources, I will try to bring it to you all. Then future trends in educational design and delivery. So this will be the learning outcomes. Develop expertise in curriculum design and pedagogical innovation, master contemporary teaching methodologies and assessment strategies. So older days, whatever we are using is gone now. Different things has to be implemented. It should be implemented and analyzed, because students, we all know that in a class of around 55 minutes, around 30 to 35 minutes is only the receptive capacity. So what about the rest of the time, right? So how best we can make use of that, so that interactive mode of discussions can happen, and so many other practices we can incorporate in each of the classes. I'll be trying to explain all those things. Then build capacity for educational leadership and institutional transformation. When every teacher tries to do the things differently, right? The institution does the things differently and in a better ways. That is where the institution also captures the attention of the others. That is how the institutions are, right? It's not that the one who follows older techniques, they will be staying there only. But the one who adapts to the changing environments with respect to educational reforms, they will be advancing, right? So therefore, it's a responsibility of everybody in the organization or education institution, especially, to see what other better institutions are doing. Those are in the higher ranks of order, right? Or how the international educational institutions are doing, what best they are doing, how their students are different, how they have been in the ranking list, etc., etc. When we compare ourselves with them, there is nothing wrong in comparing with the best performing institutions. We'll also try to see what best they are trying to do and try to adopt however much best is possible from our side. So this definition and conceptual framework, curriculum, with respect to curriculum, the total learning experience designed to promote student growth and development, that is the definition of that. Then it encompasses planned and unplanned learning experiences within educational settings. That's why we call it as that curriculum lesson plan, right? So an unplanned learning experiences also. Sometimes it's not that day to day, minute to minute, we need to be planning it. Sometimes in between, we may come across some creative ideas. So that will be unplanned, but still you feel that it is good to be taught to the students. You can incorporate that. Then includes formal academic content, co-curricular activities, and hidden curriculum elements. So systematic process of designing, implementing, and evaluating educational program. That is the definition of the this curriculum concept framework. Key components of curriculum development, because we are trying to talk about this pedagogy and curriculum, right? Be it is quantum computing or any other subject, these are the key components one should be looking through to design your curriculum and learning strategies. So needs assessment, identifying learning requirements and societal expectations, then objective formulation. So every topic, every unit or module, whatever we tell with respect to these lesson plans, it should have a clear measurable learning outcomes, right? That is what we have learned during the process of NBA also. How do you measure the learning outcomes? There should be something which says that after doing all these things, right? One is our internal assessment or learning assessment components. So those are all measurable because you will be rewarding through the marks, etc. What are the other measurable learning outcomes, right? Did after all these things, did the student try to publish a paper? Nowadays, we are not distinguishing between UG and PG. It's not that it's only PG students who should be publishing the papers. You can identify the best students. We all say that fast learners or something like that, right? So those are the measuring components where we cannot deny that. not all students are equal, right? Some are very good, some are not so good, like they need some time to learn, but still you can identify some of the best students and train them so that they implement the concept. Say they are in 6th semester or 7th semester, identify them so that whatever they have learned so far, give them a problem statement. They will be better students actually. So you can guide them so that they can publish the papers. So I think we are all doing that one. So all our final year projects, we guide them to finally publish it in IEEE conferences or the Springer conferences. So that is the extent they do that. So if we keep quiet and we assume by ourselves that, oh, they're still UG student, they can't do anything, they're still so small, something like that, we keep on thinking, but the world is moving very fast, right? So you can try all these things so that you can because they're good at learning actually. If you guide them properly, they will definitely come out with very good papers, and we have published it. So that with that my experience I'm trying to tell. So measurable learning outcomes, all these things are those. And one of the major projects got a German patent, yeah, and my guidance. So therefore we can try our best. Again, that is a measurable learning outcome. That is what the world is expecting now, right? And not only through this NBA, NAC, etc., this QS gauge world ranking also, expectations are more, because ultimately our students should not be stuck to the four walls of the classroom, learning, routine, rote learning, whatever we call it as, and writing the things in MSCs or internals or final exams, getting the marks, getting CGPAs, GPA. That is one aspect of it. But beyond that, right? So how best you formulate your objectives with respect to your curriculum, that defines your curriculum, right? For a teacher also, it's a proud moment that under my subject, these many students did these things, etc., etc., right? So like that, we need to formulate ourselves. So a lot of things we are also experimenting in our institution, like one of the LA component is Infosys Springboard certificate. So would have imagined, no, it's not, no, that is too high for our students. Let us restrict to quizzes or something like that, or writing assignments. So those days are gone now. So we need to be encouraging them to register themselves for Coursera kind of courses, certificates of their interest of domain. So cybersecurity, for example, ask them to go through what is available in those listings, and ask them to at least get one certificate by the end of the course or end of the semester. So that is one thing we are emphasizing. And this Infosys Springboard certificates, at least 20 hours minimum. And they are really good at it. We have seen that. It's not that students don't do it. It's only that our passion, our push to the students, which is resulting in all these things. And of course, all of us in PTL, all those things we all know, that was a mandatory requirements, because that is the thing which makes students to be different, right? So therefore, these are all the things which are required. Apart from that, many other things are there. I will try to bring it to all of your notice. Then content selection also, choosing appropriate subject matter and experiences. So don't just dilute the contents when defining the curriculum. See what is required. Robustness should also be there. It's not, it should not be dilute. If mathematical background is required, means introduce that. Don't leave that they have studied it in first semester, second semester, we don't have to teach it. Not like that, because whatever they have learned it over there is fundamental. It's not application oriented with respect to, say, I come from computer science background, right? So therefore, introduce them. It is required with respect to our curriculum. So therefore, don't leave that apart. Introduce wherever it is applicable. And if you feel that some of the topics are very, very tough, if the teacher only feels it is tough, then student will never learn. So therefore, introduce which is required. I'm trying to tell you, it's not that put everything which is very, very tough in the curriculum. It is not like that. Balanced one and advanced one. So those kind of content should be there. If you don't teach it now, after 1 year, that content is obsolete actually. I'm trying to tell that. So therefore, after 1 year, another concept would have come into picture, but this is already been lost to the student, right? So it is the job of we also to frame the curriculum correctly, properly, and as per the need of the hour. Then learning activity design, I was telling about LA components, right? Creating engaging and meaningful learning opportunities. I will tell some of the learning activities which we are trying to do, and also which I gathered it from the internet. Then assessment planning, developing evaluation strategies and tools. You all know that about rubrics, right? So why all those things are introduced means, so to see how best we can assess a particular student's understanding, right? So rubrics is very, very important, and design of the rubrics is important. It's not that somewhere somebody has done some rubrics, you just copy paste it over here. No. With respect to your curriculum, what rubrics parameters are required, you need to devise it again. We all know that we are all very busy, but we have to find some time to refine the rubrics as per our curriculum. So that makes difference actually. And with respect to COPO mapping or PSO mapping, which is required for assessment, final outcomes with respect to our curriculum, these things really matter, and we have to invest our time as teachers. We need to invest, reframe the parameters as per your curriculum, as per your assessment, and that should be evaluated, right? So whatever the student does. Then implementation strategy, ensuring effective delivery and resource allocation. So what is the meaning of this resource allocation, right? So therefore, every module you need to have proper timing to be allocated, proper utilization of the tools or whatever modern tools. If you want to teach it, you cannot just omit that one. So therefore, you have to arrange something extra from the industry. For example, partial delivery by the industry, right? So these are the components. We need to bring in industry people also, what best practices, what resources they are using. We need to bring it to our classrooms and teach it to the students. They also feel that, okay, this curriculum is on par with what is required by the industry. So that gap is there, no, that we need to bridge it actually. So therefore, these are the things we are also doing at our side. And I'm just bringing it to all of your notice, and I'm sure most of you are already doing this one. We can have a discussion in the end, what best practices all of you are following it out, so that we all also know that whatever we are doing and how we are doing, maybe we can bridge that gap also by following the best practices, what other institutions are trying to do. So coming back to the slides, curriculum development process, Tyler's model. There are so many models actually. One such model, what he tries to tell is, what educational purposes should the school seek to attain? We need to question. Questioning is a basic fundamental thing everybody should do. Of course, most of us are hesitant, and even our kids are hesitant to ask the questions. They will think that if I ask the question, what other my peers will think. So those inhibitions will be there actually. Still, we are not come out of it, but questioning is a basic thing. And as teachers, when we design the curriculum, we need to look into these aspects. What educational purposes should the school seek to attain by offering this curriculum? So what is it being achieved at the end of the day, right, by the school or the college? What educational experiences can be provided to attain these purposes? How can these educational experiences be effectively organized? Once we say that that's what lesson plan I mentioned, right? Lesson plan is not just in this date, in this hour, I do this topic from the syllabus, copy paste. That is out of the thing now. And there are so many other parameters associated with the lesson plan. I will show one of them at the end of the presentation here. So now we know the requirement order of the day. That is how people are changing. That is how things are getting changed. And we need to incorporate it and present it, right? So that is the important thing. So how can we determine whether these purposes are being attained? Again, after doing all these things, measurable outcomes, what we tell, right? So what are the measurable outcomes? How one that can be measured, right? Either in the form of the quizzes or in the form of the written assignments again. So it's module based, it is unit based. Again, it's not that after certain portions you do the internals. That is one of the calculations, assessments. But again, every class, if possible, I'm trying to tell, or every week, you should have something planned for your students, how you assess their knowledge, etc. So again, you can identify different set of categories, because that is the need of the hour, and we need to invest more time in bringing these changes in the classrooms. I'm just emphasizing on that. and hope all of us are trying to do that. Of course, sometimes forcibly we try to do that, but it should come passionately for each one of us so that we do something differently in the class. And that is why we have chosen this profession, right? So with that, modern curriculum orientations, child-centered or student-centered, focus on individual learner needs and development. Society-centered emphasizes on social reconstruction and citizenship preparation. Then knowledge-centered, priority on academic disciplines and intellectual rigor. Problem-centered, real-world issues and interdisciplinary approaches. Of course, nowadays it's not only one which we are focusing. Of course, we are focusing on every aspect of it: student-centered, society-centered, knowledge-centered, and problem-centered in one way or the other way, right? So everything is applicable in today's curriculum, what we are following. Then these are the traditional curriculum design models: subject-centered design, focus on academic disciplines and content mastery, organized around traditional subject areas, math, science, language, arts, emphasizes systematic knowledge acquisition and skill development, suitable for standardized education systems and assessment. But those days are gone now. I'll tell what differently we are trying to do here. Then coming back to here, learner-centered design, prioritize the student needs, interest, and developmental stages. How do we do this, right? We'll take feedbacks from the students. What is which is the most important domain you are interested in? We collect the information from so many sources, through the alumni also we try to collect, through the employer also we try to collect, right? What best is required for our students, we try to collect the information. And again, individual student needs also sometimes we need to cater to. If the student is very slow learner, again, if not able to cope up with what is being taught, so we need to have a special, different classes for them, or peer learning environments we can create, the one who is very good at understanding the concepts. You can pair them with the slow learner and ask them to conduct classes via online or something like that. Submit a report. After, they'll have to conduct the quizzes about those concepts. At least some 80% scoring has to be done by the slow learner. So that kind of encouragements we can give, both the mentor and mentee, we call it as here, peer mentor and mentee. So these kind of things we can introduce it actually. So think about that, and it is possible. And students will also be very happy that they have been identified to do something. And the one who is not so good at it, he will also think that, okay, some extra attempt is been made by the teacher so that they gain the knowledge. Ultimately, it has resulted in very good results in the semester end examinations. With that experience, I'm trying to bring to all of your notice, these experiments have really helped. Then promotes active learning, critical thinking, problem solving, encourages student autonomy and self-directed learning, utilizes differentiated instruction and personalized learning paths. Though not everything we can incorporate at this one, but differently we can have all these things in place. Then problem-centered design, focus on real-world issues. If I'm teaching cybersecurity, I will not just be teaching from the textbook, whatever they are told. The real-world applications, I bring in the industry people over here. I will ask them to give the hands-on with respect to the tools used. Of course, all the institutions are doing nowadays. I'm just trying to bring in that partial delivery by the industry that will really bridge the gap between our curriculum and the industry applications. So all the advanced tools they will be bringing into the classroom or the laboratory, and hands-on they will be doing, and therefore real-world issues they will be solving in the hands-on sessions. So that will really complete the curriculum design and implementation of the curriculum. And students will be gaining a lot from these kind of experiences or experimentations. Then integrate multiple disciplines to address complex problems. I want to give an example with respect to my major project, only the one which I guided in the previous semester. So far, like artificial intelligence, machine learning. So we were only restricting ourselves to artificial intelligence and machine learning, for example, using YOLO concept or something like that. Then we thought differently, and we had one drone setup lab, of course, with the help of a very senior scientists from DRDO, etc. They have been working here. Then I thought, why not I integrate this problem outcome output to the drone? Then I approached that professor. Then I explained this is what we are looking for. So of course, this was really a multidisciplinary, right? So our concept output till here, computer science output, and that output was fed into the drone, of course, with the help of the research associates who were present in the drone lab. So up till here, computer science, and then that has been embedded into the drone. And in the real time, the one such example was capturing. The title was wildlife animal conflict and the human being. Sometimes a cheetah, for example, it will be roaming around in a campus. So we won't be knowing where it is hiding, for example, right? With the help of the drone, we can, after chasing also, we won't be knowing where it is hiding, for example. So therefore, drone can track that one and take a picture of where it is hiding, and that will be given to our system. So like that, we know the real-time location of the cheetah. We have heard about these things, right? In University of Mysore campus or in Bangalore campus, cheetah have been roaming around, something like that. So that example we took, and this multidisciplinary aspects we introduced, and this gave a real-world addressing of the complex problems, and students were really happy that whatever they implemented is now in the drone, and drone is in real-time working, right? So like this, you associate with many people and bring in the differences in the final year projects. And they wrote a paper, it got accepted in IEEE, they published a paper. So all these things are the possibilities. It is only that we teachers need to get involved into that. If we sit, okay, my job is only 9 to 5, I will only go, I will only teach, I will only enter the marks and attendance on a day basis. Whatever job is given to me, I'll try to complete it. That is my job. It's over means it's not over. So I'm just trying to bring in, we need to have additional time allocated for the students. So which is very, very important. Okay. So you be a part of the students' project, you involve with them and bring in the differences. That makes a lot of difference to the students. Then contemporary curriculum frameworks, competency-based, outcome-based. We already spoke about that outcome-based education. Clear learning results and measurable achievements. These are the measurable achievements, actually, patents, publishing papers, all these things, right? Then integrated curriculum, thematic and interdisciplinary approaches. Interdisciplinary, I told. So all the things were there, actually. Drone plus our computer science, artificial intelligence and machine learning, etc. Project-based learning. So you can introduce small mini project-based learning things in the, for example, in all your courses, actually, learning components. For 10 marks or 20 marks, you can fix in mini project, actually. So therefore, database management systems, for example, or web-based web applications. So you can introduce all these things, and students will really become confident, actually, after doing all these things. They'll be well equipped to face the challenges of the world. And lead code, for example, you encourage establishing lead code clubs. Really, students will come out with creative ideas, actually. We need to be guiding them. Lead code, neat code, so many things are there nowadays. So therefore, it is our responsibility to guide them. We should be equipped. We should know what is required for current generation, right? So therefore, it is our responsibility to also to learn and guide the students so that they implement all these things. Suhas, can you switch off your video? It is little disturbing. Suhas KC from CIT Gubbi. Switch off the video. Our organizers can switch off his video, please.
Sure, ma'am. Yeah, I'll take a look at it. Dear participants, please switch off your video and mute yourself, so it will help for smooth running of the process.
Yeah, thank you, sir. Then 21st century curriculum design principles, relevance, rigor, relationships, and results. It's evidence. Evidence is required. It's not that only marks is an important thing, but apart from that, so many things are possible. We need to encourage them to participate in hackathons. We need to identify every teacher should be assigned a group of students. Exclusively, we should see that they exclusively participate in these kind of activities. And that's how an institution can be proudly can tell that majority of the students have participated in these kind of activities, right? That is the initiatives every organization is taking. but maybe slow down is not a thing now, but every now and then this kind of activity should be happening. Every week seminars you can organize, every week hands-ons you can organize, dedicated time you can keep it somewhere in Saturday afternoon, because that is the need of the hour. If we don't provide it to our students, they will be left behind. So that is the thing. But these are doable things. It's not a one person is doing everything. Every one of us is doing one thing, right? So like that we can distribute among ourselves. That is what we are also doing. So therefore we create a chart for a semester plan or annual plan, who is doing what by when. Maybe here on 2 days, 3 days differences might be there, but we definitely see that those kind of activities are done. So that is how students will also get really interested. So because that's what we have to do, right? So we need to organize various activities to them. In turn, they will do a lot of other things where the outcome is achieved. So pedagogy, integration of content knowledge, dynamic interaction between teaching practices and learning theories, then culture and contextual adaptation of teaching approaches. This is like inclusiveness they're trying to tell here. So we may have different kinds of students in our classrooms. They should not feel left out actually. So therefore we need to include everybody without any cultural bias. So we need to devise methods so that they will also be included. We need to hear to their opinions, their ideas. You never know what kind of ideas they will be having located to their region. For example, Smart India Hackathon. I just want to bring to your kind attention that now Smart India Hackathon is happening, right? We are internal assessments we are trying to do. One group of girl students came and they asked me to be a mentor. I suggested few of the things. Then they told, no, we are trying to do this. And what is that? They come from a village side of the Punjab. They are from that place, and they have identified that there are no health centers. Only hardly few doctors are available, it seems. Therefore, they want to create an application so that wherever the doctors are nearby, though they are not able to come to that village, but for the people of the village, they want to create an application so that, and also guide them, chatbot kind of a thing. So just imagine nowadays students are also having a lot of ideas actually. So we need to harness those ideas, conduct ideathons, special hackathons, exclusively to medical related things or agriculture related things, or whatever you feel. Keep a theme, and under that you ask for a lot of ideas, and definitely student will come out with creative ideas. So that's what we are also trying to do in our institutions. Lot of hackathons, lot of ideathons, and technological seminars, so many activities we are trying to do here. So if you see our website, a lot of things are happening. That is what we want to give it to the students. So every institution, every department is participating in various activities. So that is additional knowledge we are trying to provide apart from the curriculum. So therefore, we are not emphasizing on rote memorization, knowledge transmission anymore. But in the question paper also, if you see, it is not just explain and describe kind of questions we are setting. It is scenario-based questions we are trying to bring into the questions. And then we ask the student to analyze and give a proper answers for that. They need to analyze that case scenario and then answer some of the questions based on that scenario. Like that, we are devising our question papers also. It's not that rote learning, underwrite in MSc and SCE, explain, describe with a need diagram kind of questions. We are, as far as possible, all the Bloom's level up to L4, we are trying to ask. L5 is with respect to laboratory, some higher end projects we are trying to assign. But you can try all these things actually. Our question paper, proudly I can tell that so it's quite standard. It's not that if you think that, oh, students will not understand these kind of questions, it is better to ask only explain, describe kind of a things. We are limiting ourselves to the capabilities of our students. We have experimented this, but luckily and very surprisingly, all our students were able to answer most of the questions. So think about all these things. So therefore, this is how the changes we have been made. and I'm sure everybody agree with me actually. So scenario-based, case-based questions we ask. What is the lessons learned out of the, for example, cybersecurity? If something has happened, we give that scenario exactly and ask them what was the kind of attack and how it would have been resolved, how the incident response would have been happened if you were a cybersecurity expert. These kind of analysis questions we ask. What is the lessons learned? How preparedness you will be for the next attack? So therefore, they come out with whatever they have learned and try to integrate over here and give the solution. So which is better, just rote learning, writing something, or giving a proper solution to the case-based scenarios, right? So this is the changes we are trying to bring in the question paper. Don't think that only 3 hours is there, only 1.5 hours is there, 1 hour is there. How will they write? No, they will definitely write if you prepare them well. So this is my experience. I'm trying to bring it to your attention. This is possible with respect to any other subject also. So not only cybersecurity or cryptography, network security, which I teach, theory of computation also I have taught. There also we brought in this case study or scenario-based, how the DFA or NFA is devised for a particular problem statement. Definitely they come out with good solutions actually. So try all these things. This is really helpful. So then evidence-based, collaborative learning, that is peer interaction, which I already told, right? Mentor-mentee. So peer interaction, experiential learning. Nowadays, everybody is talking about that. Learning through direct experience and practice. So one is hands-on studies, hands-on sessions, or you can depute them to go to the industries and observe what they're trying to do there. Internships is a thing which is mandatory, of course, in the later semesters, but in between also you can try all these things. So experiential learning, they will come out with different solutions. Try for a group of people. It's not that everybody should undergo this kind of learnings. You can try different selectively. You can choose them, take the help of the teachers, take the help of the other people whom you know in the industry. So these things, extra efforts is required by us to do the things. So that's what I'm trying to tell over here. Then culturally responsive teaching, connecting to students' cultural backgrounds. As I mentioned, Punjab, for example, right? When you take an example, we should not be restricting ourselves to which place we belong to. For example, Bangalore or Tumkur or something like that. When you also should know what kind of students are present in your with what cultural background students are present in your classroom, and you need to study before you come to the class. Like, let me take an example from Nepal, for example. If you're having Nepal students, what is happening over there? So you can create interest like that with those cultural background student. Punjab, Assam, Northeast, many people will be there, right, in our classrooms, Bihar. So first thing what we do in the classroom, I try to tell, first day, first class. That is a concept that has been introduced in our institution. It's not that straight away we jump to the curriculum on the first day. We interact with every student, from which place they have come. We note it down actually, from which place they have come, where they have studied. Is it CBSE, ICSE syllabus or state syllabus? Everything we ask them to write it in a paper. We collect them and we keep it for our reference. Therefore, we got to know what cultural background they are from. If the student is from Bihar, they would have written it from Bihar, right? So we'll have a set of questions which will be filled by them, and we ask their interest. So this will bring a rapport among us and the students. So we always have to have a rapport between a teacher and the students. So when you are confident and students are confident about you, then only the classes will go smoothly. And if you listen to their questions, and you should not be curbing their questions. Hey, I know what you're trying to ask. You sit down. I'm just bringing the examples. We never should use those kind of things. Every student is important for us. That's what I also apply in my class. Every student is important for me. I listen to them, whatever their ethnicity is, whatever their cultural background is, whatever caste they are. We are not interested in them. For us, they are our students, right? So this is the approach I've been using since long. And that is how, I mean, it gives a peace of mind also, like I did good in my class. My teaching has reached all the students. We should only be looking them as students. So we should not be biasing the student based on their ethnicity or culture. So only to know from where they have come, that is good enough. Give the examples from their side, what best technology is available over there, what problem statements you create from there, how you can best solve them. You listen to them, they will only come out with the problem statements. You can guide them to solve them. So this is how we can help them actually. Then flipped classroom, I think almost most of us have already understood, because this has been told many times by many experts. Flipped classroom, we can assign to a group of students some of the portions, let them home study, do the homework, and in the classroom they will be teaching like a teacher only. So that is a flipped classroom approach. Blended learning, integration of online and face-to-face instructions, offline and offline, we all know about that. So if it is possible, we can do that also. Then design thinking is another very famous approach nowadays. Creative problem solving and innovation processes. You bring in the innovation in your teaching. You can have the diagrams, or you can have the models built by the teacher. And you can show it, for example, stacks and link list, for example, right? We will all write on the board, okay, student will understand. But exclusively, if an animated picture of the animated video of that, if you really project it, so that will give an insight how exactly things are happening. And nowadays most of the things are available online also. So you can just go to the YouTubes. For example, in the computer networks, I found a very good video where how the communication happens. A large file is there, how it is fragmented. Each fragment, again, it is put it in a form of a packet, and packet will have a header information. What are the header contents of the header information? Everything was animated very perfectly. So it gave intuition to the students how everything is happening in the computer networking world. So like that, videos you can show in the classrooms actually to create an interest. Not just our teaching, but you bring in a lot of changes like this. And after every module is done, you can conduct the quiz. Nowadays, you are having ChatGPT and other Perplexity, all those things. You can just give the contents of your syllabus of that module and ask it to produce around 50 questions of MCQs. Within fraction of a second, it will create it for you. So you will only have to cut paste along with the answers. You can ask key answers. So you only will have to either use the LMS or the Google form to create that, or just a Word file is also enough, so that without key answers, you give it to them, ask them to answer by highlighting the choices, and ask the peer reviews. Let them exchange with the peers, and you give the key answers to them. So then and there only assessment is done, right? So these things really create interest. Otherwise, they start talking, all those things will happen. Make use of those talking time to do these kind of assessments. Interesting assessments. Quiz is one such thing, but you need to plan for it for every class or every 4 classes like that. It all depends on you, and it is possible. I'm doing that. So then exit tickets, formative assessments, quizzes, peer assessments I already told. Then observations, how best the students are doing. Exit tickets, I have no idea about it. I will just, I request all of you to search through the Google search. I just missed it out over here. Then the purpose is improve teaching and learning in real time. I told, right? Once a module is over, you'll be assessing them, what they have understood. We also conduct a quiz called as a concept check feedback. After every module, concept check feedback, as good as like a course exit survey. You all know that. After the course is completed, we usually take the course exit survey. But now after every module is completed, we take the small course exit survey kind of a thing. We call it a module survey. So that concept knowledge survey we take. Therefore, we understand where the student have missed learning those concepts. So if there are majority of the students express that they have not learned it, I feel it is better to redo those kind of concepts again. Not 100% they will say no to it. At least 60% they would have understood, or 70% they would have understood, but 30% they may be lacking in some of the concepts. So therefore, it is our responsibility to cover them again so that they understand them. So these are the things which we are doing in our institution. So you can also do that. Then summative assessment, all these things we all know. Diagnostic assessment, as I mentioned, identify learning gaps. So once doing this pre-test, the concept check feedback, which I mentioned. So that also is a diagnostic assessment only, right? After completion of the course, last working day has come and you don't have the time to cover again. So those kind of things, you can do the checks in between after every module is completed. And this is an extra effort, of course. So, but once you start doing that, you will only feel very good about it, that passion we also should have. And we should not be saying that who will do all these things. I'm sure at one point or the other, we also might have expressed this is a whole lot of work. This is all clerical work, etc., etc. But that is the need of the hour, and we need to equip our students in a better way. And these are the additional things has to be done. So we should make up our mind to do all these things. That is the only thing. Then performance-based portfolio assessment, like collection of student work over time, peer assessment, self-assessment, that also I have conducted self-assessment. I asked them the key answers. I asked them only to give the marks to them. So I'm sure some of the naughty students will answer out of out, but that also you should tell them that you should not be doing that, etc. Take it lightly, that's okay. But at least they have gone through the complete quizzes or something like that. Then digital assessment, technology enhanced evaluation tools. Almost all of us are using this. Nowadays, VTO also introduced this digital assessment, or LMS is also a digital assessment only, right? And whichever softwares you are using, Continue, etc., etc. And Google Classroom, of course, which is freely available for us, right? I mean, which is available for us at any point of time. Google Classroom is also is a technology enhanced evaluation tool. We can make use of that. Of course, during Corona time, all of us have used that one actually. So digital assessment is that thing. Google Forms, you can set the marks and it self evaluates, right? So digital assessment, then authentic assessment, real world application of knowledge and skills. So validity, reliability, fairness, transparency, all these things via rubrics, you can do that. Then NEP 2020 Vision and Transformative Framework, holistic, flexible, multidisciplinary education system. It's not only core engineering concepts, but we need to bring in other things also already UGC have taken care of, and that has been percolated down to all the universities, and framework is already available. We need to only fit into them and bring out the differences. Then emphasize on foundational literacy and numeracy by grade 3. All these things we all already know it. May not be for engineering thing, but we need to know what is the essence of this NEP concept. So that new 5+3+3+4 system, all these things we know, right? Foundation stage, preparatory stage, middle stage, secondary stage, etc. before they come to our degree courses. Then curriculum and pedagogical innovations, competency-based, outcome-based, reduction in curriculum content to promote deeper understanding. Earlier, if you remember, we used to have 200 credits. Nowadays, if you see, it is 160 credits, right? 160 to 165 credits. So therefore, reduction in curriculum content to promote deeper understanding. It's not wider depth, but in depth with respect to whatever courses we have chosen, we need to have that deeper understanding. Integration of art, sports, and life skills in mainstream curriculum because of this NEP. So then emphasis on critical thinking, creativity, and scientific temper. Coding and computational thinking, that also to be introduced. And of course, we are all engineering disciplines, exclusive with respect to computer science. So coding and computational thinking, again, through these hackathons, through Lead Code and GitHub, etc. So those things has to be introduced now. There is no, like, we should not be lagging behind. In all your major project work, try to see that whatever code they are trying to do, it is plagiarism checked, and then it is pushed to the GitHub. So they need to create GitHub ID as a mentor or project guide. You also should be part of that. So many things are the requirement of the day. We should not be lagging behind. No, I don't know GitHub, etc. We should not be telling now. We also should be part of that and go hand in hand with the current generation students. So Lead Code is one such thing. If your younger teachers can also participate in Lead Code every week, and so you can tell that, see, I have solved this one. Why don't you solve this? That is the motivation you'll be creating. And there are so many other things, interview hacking, etc., etc. Those sites you will get it by anyhow, but with respect to our computer science or IT related, lead code is a major thing. Hacker Earth, Hacker Rank, all those things you promote it. You can create the clubs actually, lead code club in your institution, in your department, every week or every 15 days. So you can conduct the competitions. So many things are possible. So that's how you promote in-depth learning of what is being taught in the classrooms also. Hacker Earth, Hacker Rank problem statements can be given to the students, ask them to solve it and upload it over there. So many things you can do it. So try to explore all these things. We are also trying to do it over here, and we are organizing so many events with respect to these. And definitely students will love this. When you are behind them and you are promoting all these activities, they will never disappoint you. That is my experience. And you should have that passion to promote all these things. Take this responsibility and try to promote this. Then digital transformation, technology as enabler of personalized and adaptive learning. These are all the adaptive things we should be doing. It's not that going to classroom, teaching what is there in the syllabus, some notes as per VTU syllabus, all those things are gone, okay? So it's a different approach now. So, and that makes a difference to the students. So development of 21st century skills for digital citizenship, creation of inclusive and accessible learning environments, include everybody. Don't bias anybody. Every student is capable in one thing or the other. You need to identify them, that's it. Then track model, technology, pedagogy, content knowledge. That is called as a TPAC model, sorry. T stands for technology, P stands for pedagogy, A is for and C content, and K for knowledge. So intersection of technological, pedagogical, and content expertise. This is whatever I have spoken so far, it will come into picture in this models only. Effective integration requires understanding of all three domains, context-specific application for optimal learning outcomes. Then SAMR model, like substitution, augmentation, modification, redefinition, progressive levels of technology integration in learning, transformation from enhancements to complete task redefinition. If something is not working properly, you need to redefine everything. It requires a lot of effort and a lot of time, lot of thinking for the teachers also. So individual teacher may not be able to do, make a group of teachers to do all these things. Some workshops you can conduct among the teachers only. Some leadership initiatives are required from the institution side at regular intervals. These kind of things has to be told to the teachers, and definitely teachers will also come out with so many good solutions. So that we have seen it actually. So therefore those can be implemented. That needs to be taken by the management side. Management has to emphasize on all these things. They also should be on par with what is happening in the current world, right? So therefore, of course, definitely they will be having, and with the help of the higher ups, higher authorities like principals, HODs, senior professors, industry experts, all these things is a possibility, and it should percolate down to the junior teacher also, those who have joined newly. When you create such an holistic environment, that will double the greatness of the institution and greatness of the students. So we need to look into that. I'm just bringing to all of your notice. You can discuss with your senior management leadership team in your institution. What is the order of the day? You can go and visit other institutions like IASC, what they are following, higher institutions of learning. If you are near to IIT Dharwad, for example, IIIT Bangalore, for example, you need to go and see what is the best practices they are doing. Try to bring in some changes in your college also. That is what everybody is doing, right? So this is the need of the hour, and you can look into that. And LMS, all of us mostly are using Moodle software, and we do so many things through the LMS, like quizzes, learning assessment, we do through the LMS. So it's easy, it does self-evaluation and all those things, and course exit survey, so many things we do using this LMS. And all our course materials we upload in LMS for ease of use. We register the students over there. A lot of things are possible, and somebody should be looking through these LMS servers or etc. You have laboratory setup or server setup for exclusively for LMS, which our institution is having. Like that, I'm sure most of the institutions are having. So best utilization of those things can be done. Interactive whiteboards. Nowadays, every classroom is getting equipped with interactive whiteboards, visual and collaborative learning experiences. Then educational applications, specific subject-specific skill development and practice. So Khan's Academy, Udemy, if you go there, a lot of, with respect to your subjects, so many things are available. So you can take the cue from them and you can develop those skills in the classrooms. I am telling again, it's not that whatever textbook is prescribed, you just go through it, write the notes and deliver that in the classroom. Is only 20% is the requirement. Other 80%, you will have to go through all these other things like Udemy, Khan's Academy, Coursera. What is it that they are trying to teach with respect to this course contents? It is our responsibility to learn them and bring back into the classroom. Only then the classrooms also become very interactive. So as of now, I have never stopped. I'm already crossed 50, but I've never stopped getting the certificates. Everybody tells why you are doing like this, but it's the need of the hour, right? If we don't equip ourselves, we can't be teaching it to our students. So it is everybody's responsibility to equip ourselves, upskilling, what we call it as, learn, and teach it to the students. Then artificial intelligence, personalized learning and adaptive assessment. I'll be showing one such example. Cloud computing, collaborative projects and resource sharing. Then blended and hybrid learning models, lab rotation, flipped classroom, station rotation. Students rotate through online and offline activities. I think it all depends on your subject. Then flipped classroom, flex model, online learning with on-demand teacher support. Then digital citizenship and online safety, responsible use of technology and digital resources. It's not that resources are available at free and use it at your own wishes and whims. No, it should be like a controlled environment only. Understanding of privacy, security, and ethical considerations also to be made aware about it to the students. And you know that students take some of the things, they take it lightly. It's okay kind of a thing. No, you need to teach them where to draw a line. So all this thing with respect to this digital technology also, so that should be made aware to them. Professionally, they should be interacting with the digital things, assets or the resources. That is very important actually. Then development of critical evaluation skills for online information, promotion of respectful and inclusive online communities. So inclusiveness is another thing which is required. No student should be left behind because of their ethnicity, because of their cultural background. We are not the one to judge them because they are the students for us and they will be the students for us, because we should not be judging them, right? So our teaching should reach to every person who is sitting in the class. That is the meaning of inclusivity over here. Biasing towards the regional things is not a good thing. Then all these things which I already told. Think, pair, share is another thing. Individual reflection, partner discussion, group sharing. You can have group discussions done. Then think, pair, share. So you can pair two students and give them a topic from the curriculum only. You can give them. I'll also do the same thing. I'll identify around 6 students. I will ask them to go through around 6 slides. Each slide will be having one of the topics, and I give them for 5 minutes to go through the contents of it. And then I will ask them to come on the other side of the dais. They will be telling to the audience, other student, their peers, what they have understood from this. If something goes wrong there also, we will be pitching in to correct that one. So therefore, you have enhanced their analyzing capability, understanding capability. So every classroom, you can try this out actually. In different ways it should be done. Then in one such example I want to tell is in the cyber security, social engineering technique, how the social engineering technique is used. So for example, they will be attracting the customers to buy something. How they attract, how they lure the customers to buy something which is fake actually. So that enacting also you can role-based scenarios, what we call it as. I made them to do that, and believe me, the way definitely the way they use different tactics, the social engineering tactics, ultimately the other person yielded for that. So this is how the social engineering tactics are applied by the attackers also. And we are creating educative awareness that we should not be falling as a victim to those kind of attack scenarios. Therefore, we are creating awareness also, and we are in turn made the student to how to enact those kind of scenarios, right? So these are the role-based modelings or models, what we call it as. You can do all these things actually. Every classroom, 10 minutes, you can do this actually. And definitely student will love you for what you're doing. And definitely they have the confidence in you. Apart from that, your teaching should be good. The way you communicate should be good. Everything is a holistic process. Not only you're equipping yourself, but the students as well. So this is the requirement of the day. Then problem-based learning, then jigsaw method, expert groups teaching peers, specialized content. So like this, a lot of things you can do. Then inquiry-based learning, questioning techniques to stimulate critical thinking. So nowadays, I know that some of the students definitely ask the questions, and you should be well equipped. If you can't answer at that point of time, you can tell that I will get back to you tomorrow. But tomorrow you should not be missing. You should be telling that this is the answer to your yesterday's question. That definitely will give the confidence to the student about you. So therefore, these questioning techniques has to be encouraged. After every concept is done, you should ask the audience or the students, hope the concepts you have understood is clear. And if you have any questions, any doubts, you can approach me. Right now, if it is not right now, after the class hours also, you can do that. I'm sure most of the students will not do, but still some of the students will definitely approach you if you encourage them. So these are the wordings which make them to approach you. That approachability is another thing. They should not feel that, oh, this teacher is not approachable, all these things. And it's our holistic development also, right? So that we are reachable to our students. Then investigation and research skills development, of course, via these final year projects, you can involve with them, you can guide them, you can ask them to implement some of the other things. Definitely they come out with implementing. There's a phase-wise assessments, right? In the first phase, if you're in the panel, you can ask them to implement that. And believe me, in the next phase, those students have implemented that. So therefore, we also should be knowing what they're trying to tell it to you and what different things you can tell it to them to do that. And they will also really appreciate this kind of inquisitiveness from the teacher's side. Then scientific method application across disciplines, project-based learning, of course, we're all doing that. Then, all right, so many other things, context, input, process, product, etc., we are doing. That's what we need to do it correctly. Then quantitative measures, standardized test scores and achievement data, attendance rates and completion statistics, time to graduation and retention rates. All these things are the quantitative measures, which are all doing that. Then qualitative measures, classroom observations and teaching evaluations, focus groups and stakeholder interviews, case studies and narrative assessments. All these things are qualitative measurements. Then continuous improvement cycle, data collection, as I mentioned, that concept check feedback, right? So after every unit, if you collect the feedback from the student, you will get to know, you collect all their names, their USN, phone number, etc. In the class group, we would have created WhatsApp groups also, right? That is one of the another technique where all our communication is happening through WhatsApp groups. Google Classrooms also you can have via Gmail, group mails you can have, but WhatsApp is more convenient to all of us nowadays. So that is the best utilized tool. So you can do all these things, create the forms, get the statistics, then analyze that, then plan for the development strategies, then execute that. It's not that you only collected and you need to again redo the things or implement them and monitor it, how it is going. If still it is required, you can ask the peer mentoring concepts to be done. All these things are possibility. And you need to have a record of all these things. We all build the course files, right? I'm trying to tell from my perspectives what I do. We build a course file, go on putting everything into the course file, digitally or hard copy. So LMS is the best place where you can accumulate everything digitally, whatever you have done. So we need to keep doing on a daily basis. Then NAAC standards, NBA standards, etc. Teacher professional development, strategic framework, we are all doing it, but little more caution and little more expertise, little more inquisitiveness, little more advanced techniques to be introduced in our classrooms. Then pedagogical knowledge, technology integration, assessment literacy, cultural competence, leadership skills, all these things you need to build into the student side. How leadership skills? Ability to drive educational change and innovation. If you are a leader, definitely you will be making the student a leader. So what you want to communicate to them, what you want them to do, that also you can plan it and execute it. So you can build a leadership skill, identify the students, ask them to do this task, ask them to prepare an implementation report, explain it to the other class, other students of the class. They will also be happy actually. So like that, you're creating leadership skills among themselves also, and you're a leader, of course. So you will be driving that force. Then reflective practice, self-assessment, action research and classroom-based thing, professional learning journals and portfolio develop. Portfolio is accumulate everything, as I mentioned. Be it is student assessment or your own doings, go on collecting the proofs or whatever you have done. So at the end of the day, you are ready for the NBA as well as NAC, whatever. So you can show that this is what you have done. And it's not only that documentation, but implicitly you have helped the student to better equip themselves with your curriculum. Then so emerging trends, personalized and adaptive learning systems, global connectivity, cross-cultural collaboration. So global connectivity, like management should take a call on this, like they need to have interactions between not only industries over here, foreign institutions or foreign industries. It all depends on identifying a collective group of people who will be visiting various institutions across the globe, be it in Singapore, where most of the research is happening, be it some German institutions, majorly USA, for example. That when they do know, like they can bring in the best practices, collaborations. Of course, majority of the institutions nowadays have international collaborations. Our students will go there, they will do the project there, they submit the report here. These are the requirements. Of course, people should come forward as leaders to take out that responsibility. I'm sure most of us are ready to do those kind of things. So you can only propose it to the management. So this is the need of the hour, something like that. Definitely they will look into that, create a cell out of it, international collaborations, lot many things one can do. So that is the meaning of global connectivity and cross-cultural collaboration. Then sustainability education and environmental consciousness. Of course, nowadays, that's the need of the our UGC, NEP, etc. And in the curriculum itself, all these things are already predefined in the framework of the curriculum. So therefore, sustainability and environmental consciousness kind of things are also introduced. COPO mapping, all these things talk about this one only, right? Program outcomes, all those 11 POs. So therefore, we are aligning our teaching subject curriculum to these kind of requirements, which is a need of the hour. And in that curriculum, what teacher can do, as I mentioned, lot of things we can do. Like that, you can plan it. Activities has to be planned. That's it. So then intelligent tutoring systems and personalized learning paths, automated assessments, LMS, etc. I already told. Feedback generation also I have told. Various ways, Google Forms, etc. or exit surveys you can take. Concept feedback, concept check feedbacks you can take. A lot of ways you can generate, get the feedbacks and realign your teaching with respect to that. Then virtual and augmented reality, which is a very, very important thing which is happening nowadays in the educational field. Immersive learning experiences and virtual field trips. If you cannot go to agricultural, real agricultural thing, you can bring that agricultural farmlands to your lab only via this virtual and augmented reality setup. Every institution should have, that is my concept. Of course, we are also trying to build in one center of excellence in AR, VR, and immersive technology. So I think if everybody does in their own institutions, definitely there is nothing like that, because real world experiences you are giving, and already models are there. You need to only embed into your that Oculus Rift. All those things, all those equipments are also available. Only thing is you need to buy them, and you can ask the student to generate the projects also. So they will do it definitely, and we have seen that. So therefore, 3D visualization of complex concepts and processes, safe simulation environments for skill practice, all these things are possible via this virtual and augmented reality. So every institution should have this center of excellence, and lot many things are possible out of this. And other concepts like blockchain and digital credentials, security, if the you can have center of excellences in these concepts also, pedagogical innovations and methodologies, gamification and game-based learning approaches. So gamification is another concept. Via games, you can teach the concepts, and it all depends on interest groups. If you among your institution or you among other institution peers, you can collaborate and develop. And nowadays, you all know that how much demand is there for that, right? Once you develop these kind of learning approaches, you can popularize it through YouTube or something like that. I'm sure that will generate revenues for you. So many things are possible, and people are making use of that. So it all depends on, we should be doing that. We should not be keeping quiet. So after coming home, I will watch the serial. No, that is not going to gain in any way to you or to the students. So I think you should cut off the serials. You should advocate the same thing to the students also. They should not be playing PUBG kind of games. So it all depends on how you will be a model to them. Tell them in every very often you try to talk to them, and if you encourage them to do these kind of things, and you should be well equipped to give them the resources. So it all depends on your mutual collaborations. So mindfulness and well-being focused educational practices. Mindfulness is very, very important. So what you teach, what you talk in the classroom is also very important. So you should not be like you should be talking very, very professionally. So this is another thing. So if you talk rubbish in the classroom, just like the way they have practiced talking in home or outside world, that is not a thing. You should groom yourself to how to talk, how to behave, or the body language is also very important. How confidently you talk to the students, eye to eye contact. So all these things matters. Only when you're confident about your subject, confident about yourself. So make yourself more confident with respect to the subject knowledge. In order to know the subject, only one subject is not enough. Again, I'm trying to tell all the previous subjects are also important. All related subjects are important. Some knowledge of that you should be knowing. So therefore, data structures, design and analysis of algorithms, computer networks, theory of computation, you should be knowing what is there in those things. So over a period of time, if you're a new teacher, over a period of time, make sure that you take these kind of courses, and not just, oh, this is easy to teach, some theory subject, I will teach that, I'll be happy. No, because over a period of time, if you don't equip yourself, you will be left behind. So please equip yourselves with all the basic foundational courses also. You need to be relating them when you teach a new topic. So that's how the things are. So that's how I also have learned it. So to a greater extent, I'm little confident in the classroom when something is asked. And of course, students nowadays, they will ask a lot of questions. I can easily relate it to where that is coming from, and I can give a better solution. This is what is happening with me. So I'm sure it will be possible for every one of us. So like this, I'm trying to tell global educational challenges, skills for future workforce, adaptability is the thing. Then preparation phase, pilot implementation, full-scale rollout, key success factors, common implementation challenges. It can be with respect to new course which you want to introduce, or new department which you want to introduce, or new center of excellence which you want to introduce. All these things are the phases. You need to collect the information, you need to collect the resources, what is required if you are setting up the lab, which industry you need to approach to. So many things are there, but it's not an individual task, it's a group task. Department can help you in this one. So it all depends on how the management wants it to be done in the institution, and how the department or the head of the institution wants it to be done in the institution. So therefore, it is possible for every one of us. Only thing is we need a proper guidance, and that should be percolated down to the students. So pilot implementation means with a smaller set of things you start doing that. Once you become confident with that, you can roll out to a full extent. Then common implementation challenges, resistance to change from traditional practices. Of course, many people will tell that, oh, what is there in that? It's time consuming, resource, cost, etc. They will start telling. Then naysayers, what we call them. But somewhere we need to come out of that, because already we are in a comfort zone, right? Coming out of the comfort zone is difficult, but somewhere somebody has to start it. So it all depends on how you make a group of people, like-minded people, try to propose the things. Of course, at one point, everybody will realize, okay, this is the need of the hour. Let's give it a nod to go ahead. So that will definitely happen. A supportive system you need to have. So of course, things are possible. Then these are the key takeaways: action planning framework, date gap analysis, all these things we are doing. Previous course file and to the next year's course file, what was the gap, how to improve that, whether the outcome is achieved or not. All these things we are doing it actually. But it's not should not be only in the paper. I will be doing that, I will be doing this. You should actually implement it, that whatever you have written in a different way. Says you have a gap of 10%, for example, you would have written, I will solve more problems. Do we really do that? Yes or no? We need to question that. Okay, I have written, I will be solving more real-time problems. You make the changes, you create a different set of problem statements, and you teach them, you implement them. So that's how you keep the records, right? So that means you have done a delta changes in your approach. This is what I mean, that's the need. Everybody should be doing this. This is how the things are. I just wanted to show you like implementation of integration of Gen AI in teaching and learning processes. This we are started from this year. Till so far, we used to have lesson plan, just like general lesson plan with Bloom's COPO, and what we did in each of the classroom, which day, which time, etc. We used to write it. But now we gave this as a prompt to this chat GPT or any other AI model. You can give it and try to see how it generates, what are the things it can generate. And you can filter it out later as per your need actually. So you can do this. So I'm just bringing it to your notice. Like this was the prompt we have given. Lesson planning using AI to generate lesson plans. Prepare a lesson plan for the following topics. Include these things. A lesson plan table with the following fields. You are giving an instruction to it, right? Prompt should be proper, then the result will be proper by those kind of chatbots or chat GPT or any other AI tools. So serial number should be there, date should be there, topics to be covered, number of hours required, each class of 1 hour duration, course outcomes you mention, Bloom's taxonomy level you mention, actual date of completion. These are required columns for us. So mode of teaching, lecture, demonstration, PPT, remarks like animations, you can have activities, you can have experiments, you can have real world application, links, you can ask it to give, it will definitely give. Then suitable pedagogy methods per topic, for example, case study, group discussion, quiz, think pair, all those models we have discussed, right? Flip class, you can mention it here, it will definitely suggest. Then resources links from NPTEL, or YouTube videos, animations, PHET simulations, etc. If you mention it, it will collect it from those resources with respect to your topic and it will suggest. Otherwise, how difficult it for you to go at various places and do it, right? Luckily, we are having these kind of things and we should be using it. We should know how to use it. Then emphasize Bloom's taxonomy and active learning strategies. Then these are the topics I gave, for example, what I was currently doing. We can relate it to your quantum computing and algorithms topics also. So when you give it like this as a prompt, so ChatGPT generated so many things for us and we took what is required for us. You can filter it out also. Or if you can do all those things is well and good, but I think it's a little difficult to whatever it has suggested to do everything. You can filter out to your thing what you want to do in the classroom on a day-to-day basis. And COs also I mentioned. Then these are the textbooks I mentioned. It will not only look into the textbooks, but also other resources with respect to these topics it will generate. You can see that it generated the tabular representation and so many hours I had given, like say 7 hours of the unit 1, for example. These were the topics. It took it from the content which I had given and it also added some of the other things, number of hours required, course outcomes. So all these 5 COs I had given. If it would have felt that this topic is belonging to CO 5 also, it would have given CO 1, CO 5. Then Bloom's taxonomy level also, remember and understand. Then date, we need to put it later. That also you can prompt it if really give a good prompt. So it will definitely do that also. Then mode of teaching, it suggested PPT plus lecture. Then animations, real world cases of ethical versus malicious hacking. So you need to collect it from, or if it gives the link to that, it will also give the link to that. You can collect information from there. So everything is available to you, right? Then pedagogy methods, think, pair, share, brainstorming, things you can conduct it in the classroom. Resource links also it suggested, NPTEL, cybersecurity basics, YouTube introduction to cybersecurity. It only gave it for us. So therefore you can best make use of the AI to generate your lesson plan, pedagogy methods, resource links it will give, and what and all you can do, it will suggest. Say in the second and third day class, understand, apply Bloom's level, understand and analyze. You can see it here, right? It is different now. Then the PPT plus demonstration was there. Now it is PPT plus case study, right? Because there are so many hacktivists, script kiddies, they will be doing so many things. So what they did, like case studies, some examples also it suggested, case examples of different hacker profiles, group discussions you can have, role play, you can have different hacker roles, right? Like a white hat hacker, gray hat hacker, given a scenario, how each one of them will do the things. Maybe this is primitive class, but after the 3 to 4 units are done, again, you make them to do the role play, they will come out with better solutions. So like this, you can plan it. And this is given by ChatGPT to me. So you can use any other AI tools to generate these kind of things. You may get a better solution. See, mapping attacks to their countermeasures, right? We might not have thought about this, but GPT gave us this one. Then visual explanation of hacking life cycle, right? It gives a suggestion to users. So therefore, you can make use of this advanced technology also to better your classroom teaching and learning experiences. So like this, highlights of that was Bloom's taxonomy coverage, remember, understand, apply, analyze, and evaluate and create. All the things were introduced somewhere or the other. Say, for example, countermeasure strategies. This was the red and versus blue team debate we can have. This is suggested by ChatGPT to me because I gave the prompt, I wanted all these things, and which I did not know. Also, it has been suggested by the AI tool. So this Gen AI tool. Then pedagogy and active learning strategies, think, pair, share, case studies, real world breaches, role play, hacker profiles, hands-on lab, footprinting tools. So we arranged, because it's suggested, right? Hands-on lab is required. We arrange for partial delivery by the industry people. They came with tools, they explained in a controlled environment how things can be done, they explained. And the students were also given those credentials to go to their virtual labs and understand the concepts behind this hacking. So these things were done and really students were very happy with this. because only theoretically when we tell, they may not relate it to that. When they did it using this hands-on lab, they really were able to relate and a better understanding was created. Then group discussions you can have, quizzes you can have, interactive flow chart like phases of hacking. You can ask the students, make a group of students, let them write step by step. So like this, they will learn and come and do the things. So these are the various activities which we did. Then resources, like so many resources is there. Google hacking resources, case study examples. NIST was on another website, and you should know where to look for, right? Which information, where it is available, we should be knowing. And if we don't know, how to tell it to the students. Therefore, we need to equip ourselves with all these things, and be it any course, not only what I teach today, and tomorrow and the next semester I may be teaching some other subject, right? So it can be quantum computing also. So I need to prepare it accordingly, what is required for my course and different initiatives, and how the curriculum has to be designed, how the evaluation has to be done, what rubrics we need to create. Rubric should not be very general. It should be as per your assessment of the subject. So you need to create your own rubric parameters. So that's how the differences are. Somebody will post, this is a rubrics, means we should not be copying it that. Take that, do the parameters, rate the COPO mapping for those points also. Ultimately, you're assessing that, right? So this outcome-based education. So you're measuring through these things. So this is the whole approach. It's not like what we used to do, write the exam, final marks, results, not that. So it's extension. NBA has given a lot of inputs towards this, and these AI tools are helping us in doing all these things. So with that, I will conclude this here. Hope it was uh, understandable session from my side. And if any questions are there, we can discuss.
Thank you, Nalini ma'am, for the informative session. Participants, if you have any questions, I request you to please put it in the chat box so madam could answer them. Kiran sir, I'm not sure we can able to unmute a particular participant. I request you to put your doubt in the chat box, sir.
Hello.
Hello, yes, sir.
Madam, it was a very informative and nice presentation, madam.
Thank you, sir.
Okay, one thing is,
Hmm.
what I felt, this one feedback is,
Hmm.
for all this we can do that, but the thing is the quality of the students, how exactly they will take it, this pedagogy or any assessment.
Yeah. True,
You
true,
might
true.
have, you might have seen that the quality of the students, what we are getting,
Hmm.
they should digest this one.
I understand. If
Yeah,
I think that my students are not on par with IIT students or
yeah,
QS enabled institutions, I will not
yeah,
be able to do anything. That is
yes,
how we started with simple things. It's not that everything at one shot. So
yeah, yeah.
identify for each course one or two things.
Mm,
You don't have to do everything at once. So because
yeah,
as I mentioned, if the student have come up to your institution with a kind of a background, we know what is to be given to them. I know if we don't encourage them, they will be going behind only. If we think that looking at the face of the students also, sometimes we can think that, oh, the student might not understand. But believe me, if you start doing all these things, sir, uh,
yeah,
next day the smile on their face will be different. They
yeah,
feel
yeah,
that the teacher approached me, the teacher you ask them to come and write it on the board,
yeah, yeah.
they will be
Correct.
very shy actually.
Yeah,
But next
correct.
time you bring in the confidence to them, saying that no, you can do it when others can do, why can't you, why is it not possible to do it? That kind of wordings, when you use it, no,
Mm,
definitely they will do so. And initially in my ethical hacking class, first day when I went, I felt, oh, whatever I teach, will they be able to understand kind of a thing. but after
Yeah.
10 days or something like that, now I feel that everybody is answering.
Correct.
Whenever I ask them to write on what is the, which are the tools which are required to establish security in the NMIT, for example, our institution, then now they relate it. So one of the students told that we need to bring in educational awareness among the people in the institution. Nobody would have thought about that. So that student gave that answer. So I think
Yeah.
it is possible only if we encourage that, sir.
Yeah.
Otherwise, it is not possible. Don't think
Yes.
that students are dull. Students don't do anything. They have some poor backgrounds. They have home problems, difficulties, etc., etc. But if they're coming and sitting in your class itself is a proof that they have come to listen to you. So therefore, it is our responsibility. Don't try everything at once. Start trying slowly, one by one. Be different from what you were yesterday. That's it, sir. That's what the difference it makes. Today you have done a difference. In next semester, if you go on doing that, definitely every teacher will be doing that, and ultimately, I mean, things will be different. That's what I have observed. Create a lot of activities, a lot of clubs, and make the student themselves to be presidents or something like that. When they are in a position, no, they will think differently. So that's leadership things also we need to introduce it to them. I'm sure they will definitely do it, sir. If we start thinking like this, we'll not be able to do anything. They will not be able to do anything.
Correct.
So that's the thing, sir.
Madam, one more clarity.
Yes, sir.
You mentioned about the diagnostic assessment. Then what exactly the holistic, madam, in that holistic assessment will say?
Diagnostic in the sense concept based feedback we are taking now. Concept check feedback, we call it as. After usually what we used to do is for the NBA requirement, we used to take it at the end of the course, semester end, course exit survey,
For the
something
course
like that.
exit survey.
Yes. So that we are now micro sizing it. After every unit, we are taking it. That means by the end, student would not have studied most of the things. Our intention is every unit they should understand. By the time they complete the fifth module, for example, every university follows that, I guess. For fifth unit, they would have known all the previous 4 units. That is the intention. So micro leveling, I know it is difficult, but it is not impossible. So every unit, after every unit, we are taking that survey, and we analyze that which student have answered what, whether they have understood the concept or not understood the concept. That parameters we give in the exit survey. Unit exit survey or concept check feedback we are trying to do with respect to each module. So what is a diagnostic measure over here? We understand these many set of students have not understood this concept. How your question should be per unit, 10 questions I'm preparing and mapping it to COPOs also. And I see their answers. Some students would have told, I have understood everything completely. But some students would have put neutral. Some students would have put, I have not understood at all. So what you need to do, you need to identify peer mentoring. If it is not possible for you to retake the classes, best thing what I'm trying to do is pair. I'm making the mentor-mentee. So like fast learner and the slow learner. Who is a fast learner? The one who has understood the concepts. So identify them and map to them on one-to-one basis. And I ask them, I request them as a request because that's an additional job for them also. I request them to take at least 2 online classes with respect to that concept where the student have answered neutral or have not understood. So definitely they will come out with taking the classes, and after that they should conduct a quiz. Whether the student who understood it or not also we need to know, right? So therefore that flexibility we give it to the mentor, that student mentor, to conduct the quiz, and the student should score, the mentee should score 80% above. Only then the effort is fruitful, right? So that record keeping also, we ask them to submit a report of that. So therefore, we have identified this concept where the gap is there, and diagnostic measure we have taken, and peer mentee-mentor concept also is done. So therefore, it's a whole approach is our what we intended to do is fulfilled. So this we have introduced, and this is happening, sir.
Okay. Thank you so much, madam. Thank you so much.
Thank you, sir. Thank you. Any other questions?
Thank you, madam. Thank you, Kiran sir. If anyone have a question, you can please ask.
I think it's already dinner time and sleeping time. We
Madam,
can
before
wind it
wind
up,
up,
sir.
I have one question, ma'am, before we
Okay.
wind up.
Tell, sir.
Madam, regarding this teaching quantum computing, right? Means I am a new faculty. Like teaching subjects like quantum computing requires altogether a different mindset. Like we usually say, if you consider a bit, traditional thinking is it can be either 0 or 1. But in quantum, we say it is both 0 and 1.
Correct.
We bring a concept like superposition, and entanglement is something like a butterfly effect. Some person doing something in US is like putting effect on other person who is working in Japan or Germany, something like that.
Correct. It is
How
a difficult subject actually, so therefore one should be well versed with physics concepts and maths, of course, and all these basic fundamental courses, design and analysis of algorithm. I told about the time complexity and space complexity also, and visualization of that requires lot of study, sir. It's not that some book is given and I understand quantum computing. It is not so. So therefore, a lot of studies with related topics is required. Every word we should write it down, how it is done, and visualization is very, very important. So today I'm giving the subject as elective. You teach that. You need to put in a lot of effort over there. What related concepts, prerequisite concepts are required for that. I told about cybersecurity, RSA, etc., right? Integer factorization. We should know what is the meaning of integer factorization. We should go up to that. And these concepts of computing, quantum computing also from the physics, we need to relate it over here. So lot of reading, lot of notes making is required. Only then we can convince the students. Just like that, if we do, I don't think so. They will also be able to visualize it and you will also be able to convince it to them. So prior requisite from the teacher side is required in the form of making lots of notes, attending lot of videos or going through lot of videos in that area, and how experts in that field have spoken about and what examples they have given, what case studies they have given. You need to have all these materials. Only then you can teach this quantum computing to the students. So just like that, if you do, it's I don't think so it is justifiable. That visualization is important. What examples you give it to convince that this is how it is happening, right? They told in one of the slide that all the 16 inputs are, we can just represent it in 4 qubits. 4 qubits is enough to represent 0 to 15 of the binary. How is
at
it
the same
possible,
time?
right?
Yes, ma'am.
So
At the
the
same time,
gate
that is the thing.
notations,
Correct.
everything we need to be like simplifying it and telling it to the students. Only then it is possible to make them understandable. Lot of materials is to be with the teacher to give an example for that.
Sure, ma'am. Okay. Yeah.
Yes, sir.
Thank you, ma'am.
Okay, thank you. Then shall I wind it up?
Sure, ma'am. Yeah, thanks for this informative session. It was very informative for especially new faculties like me. I'm sure it helps for all the faculties because it worked like a skeleton for whatever course they are pursuing it.
Yeah. It's not
So
only quantum. Any course, whichever you teach, be it is theory of computation, be it is computer networks, all these things are the requirements. So make use of the ChatGPT or Perplexity AI to develop a lesson plan. In that, which is applicable for you, you can choose. At least in one of the courses at regular intervals, you conduct these kind of activities. Keep a record of that. In the next semester, you can improvise on that. So this is the need of the hour. And lot
great,
of
ma'am.
information you collect itself. Not only, for example, one book is prescribed, all related informations. Whenever you read a statement, no, if you come across some new word, what is that related to that? You need to have information. This is how, like notes, you need to have a complete notes about that. That's what I
Right.
also write lot of notes, right? When I write, I know what I am writing and where I need to write what. So if you see my notes for every course, I'll be having around 200 to 300 page of notes, handwritten notes. Everybody will like they joke about me. How come you? I mean, you write all these things, and I have not seen many people writing. But I am passionate about writing. So when I write, I know what exactly I want to teach. And I make the students also to write in the classroom. I know students will not listen to you. They also don't want to. They are more prone to PPT readings. But still, I emphasize at least one or two concepts are written in the classroom. So this is some additional things which I do. And all my notes, all my subject notes, around 200 to 300 pages with all different examples, with the definitions, different definitions I will be having, because I collect it from various resources and I make my own notes. That's how I become confident. If something is asked, I can relate it what I've already prepared. So that's how I'm able to give it to them. If I don't know also, I will tell them that I will get back to, but that situation has not occurred to me. Luckily, I have answered all the questions to whatever they have asked with the examples. That is a preparedness one should be having. That's what I feel. That's it. And it is possible for everybody. Preparedness, that's it. Come back to home and watching the serials is not a thing. Because I feel this is my this one
Yes,
advice.
ma'am.
Please don't feel.
Even I agree that
Yeah.
writing is equivalent to n times reading. That is
Yes,
what.
yes, yes. When you write it, you know what you're writing, what is required actually. And teaching will become easier actually. So I request everybody to follow that. It will really help actually.
And what I observed, ma'am, all the methodologies which mentioned, it's
Mm.
they are all have a coming point that
Mm.
faculty and student should get closer. That is what it is.
Exactly. That is what the intention. You should not be keeping the students like, no, no, you don't come near to me. No. When you have a rapport with them only, your knowledge is disseminated to them actually. You talk to them freely. Let them talk to you freely. That is more important. So they should feel that something is there with this teacher. That when you create it, no, you will be surprised. Wherever you go in the corridor, they'll be wishing you actually. That is a blessing for us, right? For the teachers.
Yes,
So
exactly, ma'am.
that's how it should be, I feel.
Yeah. Thanks again, ma'am. It's
Okay, thank you all
uh,
then.
it's
Have a
good to
good
have
night.
such a
Yeah.
wonderful teacher among us.
All of us are wonderful, actually. Only thing is, we need to little more work towards that. That's it.
Yeah, exactly, ma'am. Yeah,
Yeah.
yeah. I have felt every teacher special, right?
Yes, yes. Every
Every
teacher will
student
have
and
something or the other.
yes, ma'am.
So only thing is we need to equip ourselves. That's it.
Yeah. Sure, ma'am. Yeah. Thanks
Mm.
for all the guidance and the advices, ma'am.
All right. Thank you. Thank you so much.
Yeah.
Right.
Thank you, ma'am.
Good night to all of you.
Thanks everyone for attending the session. So it's time to wrap up. Before we wrap up today's session, I would thank Dr. Nalini ma'am for providing us a valuable insights, and I would also thank all the resource person who engaged us for the today's event. And before closing, I would like to inform everyone that tomorrow will be the day 6 and last day of our FTP session. And tomorrow's session begins at 2 p.m. So I request everyone to be ready and make yourself available from 2 p.m. It will not go till late night because we have something valedictory session and all plan. I think it might go probably till evening 7 or so. So I would request and the attendance would be taken for tomorrow's sessions as well. There will be three sessions starting from 2 o'clock in the afternoon. So I request everyone to please join. The link will be shared in the group. I request everyone to go through that link and join on time and provide your feedback and attendance for the timely completion of your certifications. So thanks everyone for being with us for this late. So yeah, So I'll quickly wind up. So have a good night and yeah, take care. Let's meet at tomorrow afternoon 2 p.m. Thank you all.
Thank you
Good night.
for giving me an opportunity, and I congratulate all of you and Sridevi Institute of Engineering Technology for organizing this wonderful FDP, ATAL FDP. Thank you
Thank
all.
you, ma'am. Thank
Yeah.
you, ma'am. The pleasure is entirely with us. Yeah.
Thank you. Thank you. Bye.
Thank you, ma'am. Bye. Good night.
So, dear participant, the session will be going on another 5 minutes. If anybody is not yet fill the feedback as well as certains, kindly do it fast.